During combat operations, the resupply of forward units can be accomplished by helicopters. Normal activities will see the medium transport helicopter working between the Corps and Division administrative areas. In urgent situations, supplies can be moved directly to Forward Service Battalion locations. When the tactical situation permits, critical supplies such as ammunition, engineer stores, and fuel can be moved directly to a delivery point or to the A echelon location. Utility helicopters are used when the commodity to be delivered is in smaller unit lots, or if the tactical situation would place the medium transport helicopter at an unacceptable risk. Resupply helicopters are not limited to roads or to the condition of the ground. They can react quickly to situations. Large or bulky items can be moved without difficulty, and point-to-point operation reduces delivery time. There are, however, certain inherent disadvantages in using helicopters. They may be limited by darkness, weather, and availability. Their lift capability is affected by altitude and temperature. Landing on loose or sand surfaces can severely damage aircraft components, equipment, and can cause casualties. Helicopters are easily detected, are vulnerable to enemy ground fire. Helicopter operations require detailed coordination and special training by all involved personnel. A forward battalion has requested an emergency replenishment of combat supplies, stores, and critical spare parts. A vehicle packet from its affiliated service battalion was dispatched with the required items, but because of enemy activity, was unable to proceed to the delivery point. The Supply and Transport Company Command Post advised the Service Battalion Logistic Operations Center that the DP could not be activated. The LogOps duty officer reports the problem to the Division Service Group headquarters and requests a direct delivery of combat supplies by helicopter.
Yeah, just received a warning order.
He details the commodities required and confirms that the selected DP site was also suitable as a landing zone. The Medium Transport Helicopter Squadron's liaison officer at the DISC Group headquarters approves the feasibility of a resupply mission and indicates that an aircraft is available for the mission. He advises the Division Aviation Wing headquarters of the pending task and initiates the coordination for the required airspace. Concurrently, the DISC Group headquarters duty officer warns the replenishment point to prepare a slung load of the required combat supplies, which is to be moved from the RP to the DP by a medium transport helicopter. This aspect of the plan is being coordinated by the Transport Squadron ALO at DISC Group headquarters. The balance of the load, which contains repair parts, technical stores, and other needed items, is to be moved from the Service Battalion location to the DP-LZ by a helicopter from the Wing Utility Squadron. The information on the helicopter resupply mission is passed by DISC Group headquarters to the Service Battalion LogOps Center and the Brigade G4 staff, who in turn tells the unit that the mission is underway. The packet is directed to break contact and return to its company location. Detailed mission briefings take place while the aircraft is prepared for departure. The receiving unit DP site commander has been advised to expect a helicopter resupply mission. The LZ party is briefed and given their orders. They then prepare the LZ using the following criteria. The LZ must have a hard surface and be free of rocks and debris, which can damage the aircraft or injure personnel. The ground should be level. This factor is critical for night operations. The LZ must be large enough to accommodate the type of helicopter being used. A 75-meter zone is an acceptable planning figure for a transport helicopter. And the approach and departure paths must be clear of obstacles and preferably facing into the prevailing wind. Once the LZ has been prepared, the controller lays out the night landing aids. These provide the location of the LZ, the approach and departure paths, and the touchdown points for the helicopter and any slung load. In the meantime, the medium transport helicopter has departed its squadron base for the RP. At the RP, the loadmaster checks and accepts the load for slinging, and the pilot's information is updated with additional details on the LZ local enemy situation, including the enemy air and anti-air threat, and the description of the LZ. Just prior to the arrival of the medium transport helicopter, the LZ controller activates his night landing aids, and if necessary provides terminal guidance instructions, and a radio homing transmission which will activate a direction finding device in the cockpit of the helicopter. Such transmissions are minimized so as not to compromise the situation. Speed is essential in clearing the LZ, as the helicopter activity is likely to attract enemy attention. In this case, the medium transport helicopter arrives, drops its load, and departs. The utility helicopter follows with its load. Prior to departing, it takes on any casualties, stores, and mail, as well as the paperwork for the following day's DP requirements. Once the receiving unit has loaded up its supplies, it moves out, and the DP site commander reports DP closed. For successful helicopter resupply operations, it is important that the receiving unit is prepared to operate the LZ, should it be necessary. The selected LZ must be adequate for the type of helicopter, and it must be confirmed by a detailed reconnaissance. Air crews must always be prepared for en route delays, loss of communications, or sudden changes in the plan. Staffs must quickly report holdups which might be resolved by a helicopter resupply mission.
Company BMP's moving west.
This production has described a simple alternative means of completing a DP operation, wherein aviation resources have been capable of reacting quickly to an emergency resupply situation.
Airmobile operations are those in which combat forces and their equipment move about the battlefield in helicopters under control of a ground force commander to engage in ground combat. Airmobile operations are usually executed in lightly defended areas and are accompanied by extensive fire support to suppress enemy air defense and direct fire weapons. They are characterized by joint planning of all airmobile force activities. An airmobile force has been designated as part of the division reserve. The airmobile force commander has received orders to seize key terrain held by an enemy platoon on the division's flank. This task will be executed by troops earmarked as the division's airmobile force, and they have planned and trained for such a contingency. This operation will be conducted as a deliberate helicopter assault by an airmobile company group employed as part of the Division Reserve. 12 utility and 6 observation helicopters have been assigned to the mission. Fire support includes field and air defense artillery and could include attack helicopter and close air support missions. A joint planning group has been convened to work out the details of all aspects of the operation. The operation will be planned in reverse order of execution, starting with the ground tactical plan, the landing plan, the air movement plan, the loading plan, and the staging plan. Fire support, suppression of enemy air defenses, communications, electronic warfare, and logistic plans are made to support each phase of the operation. All plans are directed towards the success of the ground tactical operation. Throughout the force, general preparations are underway, such as drawing ammunition, feeding, resting, and initiating liaison. In the formulation of the ground tactical plan, the major concerns of the lifted unit commander are the rapid landing and buildup of his entire force, subunit integrity, surprise, anti-armor protection, security, and such variables as heavy losses and weather. Aviation planning must consider the use of attack helicopters for direct fire, anti-armor support, and the suppression of enemy air defense weapons. Observation helicopters for security, early warning, fire control, and communications assistance, as well as any available medium transport helicopters for resupply and evacuation.
4501 and 4500 are going to be adjusted.
The Airmobile force should be landed as close as practical to the objective. The landing plan must consider the availability of landing zones, the size of force being landed on first lift, the landing formation, the preparation and security of the landing zone throughout the operation, and of the in and out routes for initial and follow-on waves or insertions, and the possible insertion of ground pathfinders or advance parties.
Fighters coming out of Cold Lake, deploying to
The air movement plan is the responsibility of the aviation mission commander.
forecast for the Edmonton area.
Return to the holding area.
The air movement plan is developed to meet the ground tactical and landing plans and includes operational information provided by elements of the airspace control system. It includes an air movement table and a flight plan. The air movement table outlines the loads of each helicopter, the elements to be lifted, times and locations for pickup, landing zones, holding areas, arming and refueling cycles, extraction, and miscellaneous information. The first half of this table often serves as the air load table. It has been prepared primarily by the lifted unit's 2IC. The remainder has been prepared by an air liaison officer and includes scheduling of aircraft and assignment of routes and pickup and landing zones. The flight plan portion of the air movement table includes routes, altitudes, and control points to landing zones, aircraft formations, timings, and speeds, control measures, protection, refueling, emergency procedures, and locations and timings for suppressive fire against enemy air defense sites. The detailed load planning of each helicopter is done by the air liaison officer and the lifted unit commander's second in command. It specifies the distribution of loads to aircraft, slung or integral loads, and a load preparation schedule. It also includes a priority for lift in the event of unserviceable aircraft and the placement of commanders. The loading plan also incorporates the location, layout, and operation of the pickup zone, including recce details, spacing of aircraft landing points, landing formation, loading times, and the identification of the lead chalk for the lead aircraft. This identification is usually done by a man with panel marker vest who makes himself visible to the aircraft on final approach. Individual aircraft identification can be accomplished by chalk number cards. The staging plan marries up the combat force with all its equipment and supplies and the helicopters providing the lift. It also includes times for orders, preparation of equipment, assembly, rehearsal, routes to the pickup zone, coordination details for the movement of men and equipment through areas occupied by other forces, control details for the pickup zone, and arrangements for security.
Be able to give us full support on that. Of course, we might have to think about smoking the area.
Fire support must be integrated with the ground tactical plan, the landing plan, and the air movement plan. It is coordinated and controlled through the Airmobile Force and Appropriate Formation Fire Support Coordination Center.
3 Charlie 501, a Tiger, go ahead.
We have to sit down and coordinate the fire plans for the various...
Fire support includes a fire plan for the suppression of enemy air defense elements and may include preparatory fire around the landing zone to neutralize suspected enemy positions and covering fire for maneuver of the attacking force. It would normally only include fire provided by artillery, mortars, attack helicopters, and close air support aircraft. The SEAD plan is built up at the FSCC and uses all available fire support to suppress or destroy enemy air defense weapons systems. This fire support should cover the entire flight route. It includes smoke, chaff, and/or electronic countermeasures to neutralize enemy air defense systems and known or suspected enemy positions. It must be flexible enough to engage targets of opportunity. During the joint planning phase, details pertaining to command and control of the operation are resolved. This includes such considerations as the location of headquarters and commanders, the use of forward airborne command posts, radio rebroadcast, radio silence, and the establishment or joining of the appropriate combat radio nets. In addition, arrangements for electronic warfare support are made through the division to include the assignment of helicopter-borne jammers to deny the enemy use of his tactical communications or radars during the landing and ground phases of the operation. The communications structure for an air-mobile operation comprises both air-to-air and air-to-ground radio nets. The air-to-air nets are used by the Aviation Mission Commander and forward air controllers to control aviation elements and tactical air. Air-to-ground nets will include the lifted unit net, the immediate higher headquarters command net, and the artillery fire direction net. Although a logistics plan is not a specified phase of the planning sequence, one must be developed to support all phases of the operation. Logistical planning for an air-mobile operation will include specific concerns for the aviation element, such as helicopter arming and refueling, tactical resupply and casualty evacuation, and the subsequent logistic requirements of the lifted unit commander. Once the joint planning is completed, the lifted unit commander and aviation mission commander can return to their units to individually complete the planning and coordination required for their specific part of the operation.
Keep an eye on number 2. Because sometimes it gets a problem.
The operation is now rolling, with all activity taking place on a schedule linked with H-hour. The staging phase has begun well before the lifted unit commander and aviation mission commander started their detailed planning. After receiving the warning order, the force carried out preliminary planning, rehearsals, and load preparations. The reconnaissance and organization of the pickup zone is carried out by the Air Liaison Officer and the lifted unit commander's second in command. Helicopter landing points and chalk holding areas are allotted to maintain maximum control. The establishment of any forward arming and refueling points would also be a part of the concurrent activity. Troops now move to the assembly area, regroup, feed, rest, check equipment, and receive final briefings and orders. Here they pick up any bulk loads which have been dumped and prepare them for movement to the PZ.
Le vent vient du nord-nord-ouest. Ça va être nuageux. La compagnie C occupera une position d'arrêt au centre de masse. Coordonnées 131694.
Concurrent activity includes formal orders being given by the lifted unit commander and the aviation mission commander at their unit locations. Troops are formed into chalks and moved to their pickup zone holding areas to await the arrival of the helicopters. The loading phase commences with the arrival of the helicopter force at the pickup zone. The Air Liaison Officer, assisted by the lifted unit second in command, ensures that the pickup zone is properly marked and supervises the overall control of the incoming helicopters. Activity on the pickup zone is controlled by the lifted unit second in command, together with the Air Liaison Officer. Loading activity takes place in accordance with load tables, which detail the positioning, scheduling, and matching of loads to aircraft. Loading of tactical groupings has taken place in the correct sequence as required by the ground tactical plan. The main body departs along routes selected to minimize enemy observation and fire, to aid in deception, to provide ease of navigation, and to minimize interference with friendly positions and fire. Multiple routes may be used to improve surprise, but this adds to the difficulty of controlling and synchronizing the operation and increases the requirement to suppress enemy air defense fire. The routes are translated into corridors based on air control points. Additional control measures include the start point, communications control points, rendezvous points, holding areas, and finally, a release point. When possible, the formation will be provided with an armed escort to suppress enemy air defense and ground fire which may be encountered en route, to provide fire support at the objective, and to act as a perimeter guard. The escorts may accompany the force from the beginning or meet with it at a designated control or RV point. In addition, close air support aircraft may be assigned which would engage both ground, air defense, and air targets. Known air defense threats will be suppressed by artillery or tactical air on a planned basis. A part of the artillery fire plan is normally dedicated to the suppression of targets of opportunity by fire missions, directed by the supporting observation helicopters in contact with the supporting artillery unit. All fire support requirements are controlled by the force FSCC. As the formation approaches the objectives, It is split into smaller elements to allow flexibility of maneuver, to conform to terrain, and to respond to threats. Speeds used allow the formation to adjust the timings for the escorts to catch up after they've engaged targets en route. Element configuration enables an all-round lookout for defense against an attack. The lifted unit commander must be able to communicate with any pathfinders, the Airmobile Force commander, and with the Aviation mission commander in order to be able to react to changing circumstances. For this operation, sufficient time was available for the insertion of ground pathfinder teams, which were to locate, check out, secure, and mark the landing zones. All details of their insertion and tasks were integrated into the Airmobile Force commander's plan from the outset.
Echo nil.
Ground pathfinder activities must be included in the fire support, electronic warfare, SEAD, air movement, and landing plans to ensure that overall mission security is not jeopardized. As H-hour approaches, the fire plan in support of the landing phase is initiated. Ideally, a forward observation officer would be deployed with any advance party to direct the covering fire support for the force. An airborne observation post would also be employed to engage targets of opportunity using artillery, attack helicopters, or ground attack aircraft. Preparatory fire will be provided by assigned divisional artillery and close support aircraft, and could also be provided by artillery moved by helicopters into a distant fire base on an earlier insertion. Fire support may also be provided by attack helicopters. A Pathfinder helicopter, having checked the routes, assessed LZs and coordinated ground pathfinders, joins up with the assault force at the RV and briefs them on the situation. As the force passes the release point, the landing phase begins. Normally, the force will split and proceed to separate landing zones. In this operation, the plan calls for a mortar element to set up a fire base. It has deployed approximately 2 kilometers from the objective. The assault element lands approximately 800 meters from its objective. Supporting fire is brought down by the mortars and artillery to fix the enemy and to provide covering fire. The LZ was chosen for the protection it affords against direct fire from the objective. Infantry support weapons are landed simultaneously with the assault element, but on a different LZ. They move to establish a fire base to support the assault, located approximately 500 meters from the objective. After the insertion, helicopters may be tasked to stand by for casualty evacuation, resupply, or extraction tasks. Helicopters so tasked would normally proceed to the forward arming and refueling point, refuel, and move on to a holding area. Where they wait for orders from the lifted unit commander for their next task. Once consolidation of the ground force is complete, the assault starts. During the ground tactical phase, fire support assistance is continued by the attack and the fire control helicopters. They remain on station to assist the lifted unit commander and his forward observation officer with observation and fire direction, as well as the control of close air support aircraft. Observation helicopters can provide radio rebroadcast assistance for the lifted unit commander and forward observation officer. Others may be used as forward command posts to control aviation support to the ground operation. The Airmobile Force relies on helicopters to provide logistics support to the ground operation until link-up is completed. Casualties would normally be evacuated by returning empty logistics support aircraft. As well, dedicated medical evacuation helicopters may be assigned from Corps. Once the ground force achieves its objectives, the airmobile aspect of the operation is concluded. This production has illustrated an airmobile operation based on a company group in an assault. The principles and main elements of activity apply to virtually all airmobile operations, regardless of size.
The versatile aircraft of the utility squadron perform a wide range of tasks for land formations. Whether a single utility helicopter is tactically employed for emergency combat resupply, or a large formation executes an air mobile operation, a land commander has the support of a highly mobile aerial platform. The utility squadron is similar to the observation squadron in its communications, liaison officer structure, capabilities for camouflage and defense, movement, and limitations. The repetitive details of these will not be restated in this production. The utility squadron is organized into a squadron headquarters, 2 aircraft flights, a servicing flight, and an administrative flight. The personnel structure of the squadron comprises pilots, flight engineers, aircraft technicians, combat support, and combat service support personnel. Its equipment includes 24 helicopters and approximately 60 wheeled vehicles. The squadron's level of self-sufficiency is normally limited to first-line administrative and aircraft servicing support. It is capable of deploying as a self-sufficient unit and carries a 3-day basic load of combat supplies, including aviation fuel. The squadron is normally located in the division administrative area and functions in support of the division as a whole. Elements could, however, be grouped with a forward brigade for a specific task, such as a troop lift or a resupply mission. The squadron subunits can be readily deployed to conform to the ground and to the available concealment, and can establish a forward tactical base to support its aircraft when undertaking a continuous long-term tasking. The aircraft operates anywhere up to the forward edge of the battle area, where tactical flying techniques are necessary to ensure aircraft survival and mission accomplishment.
Operations can be conducted beyond the FIBA, but because of the high risk involved, these should be the exception rather than the rule. When flying in the area from the rear of the forward brigades to the FIBA, the air crew will generally rely on contour flying techniques to enhance survivability. Here, the pilot flies at a low altitude generally conforming to the contours of the ground. The flight is characterized by varying altitudes and constant airspeed. The role of a utility squadron is to provide the division with tactical and logistic lift, including the movement of infantry, anti-armor teams, aerial emplacement of scatterable mines and ground sensors, reconnaissance and engineer parties, combat resupply, and support to forward replenishment operations, command, liaison, and communications assistance, as well as aeromedical evacuation. It also provides the aerial transport for airmobile operations and the lift of fire support elements. Utility helicopters can be armed for self-defense and suppressive fire against ground targets during airmobile operations. However, this significantly reduces the lift capability of the helicopter. Blocking forces may be inserted into areas not readily accessible to ground forces, and forward defensive elements may be augmented with anti-armor teams equipped with anti-tank guided missiles. Utility helicopters can be used to dispense scatterable mines in a combat zone. Filled mine dispensers are picked up from an ammunition point, and a minefield can be quickly laid to counter enemy movement. Unattended ground sensor stations may be rapidly emplaced on difficult terrain. Engineer reconnaissance teams and other elements can cover distances by helicopter in a fraction of the time required on foot or by vehicle. Engineer teams can be quickly moved to prepare bridge demolitions, road craters, and other barrier tasks. In an urgent situation, the resupply of forward units can be accomplished by utility helicopters. Critical supplies such as ammunition, engineer stores, and fuel can be picked up at service battalion locations or from delivery or replenishment points and delivered rapidly to an administrative or fighting echelon. The squadron may be tasked to transport replenishment items for the attack squadron's forward arming and refueling point. They may also be involved in its initial deployment and subsequent relocation. Command and liaison missions provide commanders and staff with the means of rapid transit in the execution of battle procedure, facilitating face-to-face command. An unmodified helicopter can provide a commander with a limited airborne command post capability, while a specially equipped aircraft can provide a complete command post facility. While the task of casualty evacuation lies primarily with the Corps Air Ambulance Squadrons, the squadron's utility helicopters can be employed for aeromedical evacuation of patients. This function would be performed as part of the return portion of a resupply or other mission. There is no unit in the division that cannot be supported by the utility squadron. Its helicopters can quickly move troops, supplies, and equipment about the battlefield, completely unfettered by obstacles and terrain. It provides a commander with a unique form of support during all phases of the battle. The Tactical Aviation Group Medium Transport Squadron moves combat troops, equipment, supplies, and personnel for tactical, combat support, and combat service support operations. The assignment of a medium transport squadron to the division is normally made by Corps to support logistics operations.
2,000 meters
The GOTPS Tactical Aviation Group places medium transport helicopters in support of the division service group, and the squadron provides a liaison officer to the Disc Group Logistics Operations Center. The squadron is organized into a headquarters, 2 aircraft flights, a maintenance flight, and an administrative flight. It is capable of deploying as a self-contained unit and carries a 3-day basic load of combat supplies, including aviation fuel. The squadron headquarters is manned and equipped to provide command, control, and communications functions. The aircraft flights have sufficient crews and equipment to provide continuous aviation support. The aircraft maintenance flight is manned and equipped to provide first and second-line maintenance for its own aircraft, including mobile repair teams and some workshop support. The administration flight is capable of providing first-line administrative support in terms of supply, medical, food services, transport, and vehicle repair activities. The squadron personnel complement includes pilots, flight engineers, loadmasters, aircraft technicians, and combat service support personnel. Its equipment includes 8 medium transport helicopters and 50 wheeled vehicles of various types. When elements of the squadron are deployed in support of division taskings, their communications rearwards to the squadron are effected through their LO at located Disc Group headquarters or through the area trunk system. When operating forward, individual helicopters join a local net at their destination LZ. The squadron normally deploys in the Corps administrative area, but may relocate forward within the DAA if it proved to be the best location from which to carry out its tasks. The effectiveness of the medium transport helicopter on the battlefield depends on adequate planning, proper tasking, and appropriate operational techniques. Its use in the forward area must be considered in view of subsequent risk of loss of a valuable transport resource. Various limitations must be kept in mind when planning the employment of the medium transport helicopter in the forward brigade areas. These include staying far enough away from the forward edge of the battle area to be out of detection or engagement range of enemy air defense guns or anti-aircraft missiles. Not flying into a landing zone which is under enemy observation and where their field artillery could be used. Not normally flying across the FIBA. Likely requirement for Pathfinder support, and designing the loads for minimum unloading time and for cross-loading if required to utility helicopters. Additionally, the MTH would only be used in the follow-up phase of an air-mobile operation. With its instrument flight capability and the appropriate electronic navigation and approach aids, the medium transport helicopters can operate in darkness and in instrument conditions. Aircraft must operate within the constraints imposed by the airspace control system, which, when combined with the effects of difficult weather, can produce a considerable slowdown in the flow of supplies. When flying in the division rear area, crews will generally use low-level flying techniques. Here, the pilot flies at low altitude to avoid detection or observation. The route generally follows a straight line, maintaining a constant altitude to clear the highest en route point. Direct low-level routing is coordinated by the aviation staff in the airspace and fire support coordination centers at all levels. It is used from the core area to landing zones forward of the division or brigade rear boundaries. Execution of the primary role of the squadron requires that its control and direction be delegated to Disc Group headquarters and that the squadron be integrated into the transportation system. This provides a guarantee of support to the logistics planner and ensures that the helicopters are employed as a complementary transport resource without tasking delays and eliminating conflicting priorities. Proper employment of medium transport helicopters is based on the presence of a Squadron LO at Disc Group headquarters and by selection and identification of missions that, based on the tonnages involved, are suitable for movement by air. The majority of logistics tasks suitable for helicopter lift, such as the movement of combat supplies, defense stores, and vehicle recovery, are controlled through the Disc Group Log Ops Center. Aircraft allocations to tasks are made by a block of hours, not by individual aircraft. When undertaking support to specific tactical operations, disruption factors must be built into the overall logistics plan. The extent and consequences of this disruption must be considered before assigning tactical operations tasks. In any type of activity, its pilots must be well briefed on enemy locations, routes, and the air situation. Normal operations will see the medium transport helicopters working between the core administrative area and the DAA. In urgent situations, resupply for such critical items as ammunition, fuel, and engineer stores can be made directly to service battalion locations and even to gun positions or rear echelons. Resupply of ammunition and fuel will constitute a major portion of the medium transport helicopter's tasks. These loads are ideally suited for standard load configurations using pallets, nets, or bladders. Other tasks involve helicopter support to relocate and resupply the forward arming and refueling points. The transport helicopter is also an excellent vehicle for the quick deployment of 105 towed gun detachments. One medium transport helicopter can lift 3 gun detachments, complete with 100 rounds of ammunition. Defense stores and mines will be in heavy demand. The medium transport helicopter is an ideal vehicle for the rapid transport of these items, as well as moving or relocating bridging. The medium transport helicopter has the capability for mass casualty evacuation. It can be quickly fitted with up to 24 litters. Aircraft returning from the division administrative area can provide a ready resource for aeromedical evacuation to core medical units. It is also an excellent resource for the recovery of downed aircraft and critical equipment. These activities involve a minimum of load preparation and ground support. During battle, the medium transport helicopter is a valuable lift resource in support of anti-armor, air mobile, and rear area security operations. Here, their optimum use is to carry follow-up echelons, support weapons, and essential resupply items. The maintenance flight concentrates on quick turnaround repairs, which assure a high degree of aircraft availability. This is accomplished by component exchange of items such as avionics, engines, transmissions, and the like. Spares for these activities are provided by Corps directly to the maintenance flight. They may also be funneled through the replenishment system to the spare parts section of the appropriate maintenance squadron. Aircraft requiring extensive repairs are backloaded to core maintenance facilities. Early recognition of the airlift requirement is essential to allow the best response in terms of mission planning and preparation of the loads to be transported. As an alternative to surface transport, medium transport helicopters can provide added combat flexibility by rapidly moving combat supplies and, if necessary, combat elements over broad areas that may be impassable or difficult for vehicles.
Helicopters employed by the Tactical Aviation Wing require 3 levels of maintenance to ensure their continued support of the land forces. Level 1 maintenance, such as servicing, replacement of minor assemblies, systems replenishment, and minor repairs, is accomplished in location by the operational helicopter squadrons, while Level 3 maintenance is carried out in the core rear area or at contractor facilities. The role of the Tactical Aviation Wing Maintenance Squadron is to provide second-line aircraft maintenance support to the wing. This support is considered to be any aircraft maintenance activity taking in excess of 2 hours to complete, and includes providing aircraft spares and replacement equipment to the squadrons within the wing. The Maintenance Squadron is an integral part of the Tactical Aviation Wing. The squadron is organized into a headquarters, a maintenance flight, an avionics flight, a maintenance support flight, and a service support flight. There are 20 military occupations represented in the squadron. The squadron commander and his deputy are aerospace engineers, as are the maintenance, avionics, and maintenance support flight commanders. The service support flight is commanded by a logistics officer, and experienced pilots fulfill the dual role of maintenance test pilots and operations officers. Aircraft maintenance activities are carried out by technicians from 10 aircraft technical trades, and a further 7 trades provide the required support functions. The squadron's personnel establishment totals approximately 250, all ranks. The headquarters incorporates a command post and a maintenance control center. The command post function oversees all squadron operational and tactical activities, including preparation of movement orders, communications, mobile repair team dispatch, as well as test and ferry flight assignment. The scheduling and control of aircraft maintenance activities, including technical administration and liaison, is carried out by the Maintenance Control Center. The maintenance flight's major responsibilities are the completion of periodic and supplementary inspections, snag rectification, and the provision of personnel to form mobile repair teams. The avionics flight is responsible for effecting second-line maintenance relating to avionics and instrument and electrical systems. It supports the maintenance flight with avionics and instrument electrical workshops and provides personnel for MRTs when required. The maintenance support flight is responsible for all refinishing and workshop activities, for the maintenance and repair of safety equipment and air weapons, for the operation of the tool control center, and for the maintenance of all aircraft support equipment. It assists the other flights as required and also provides personnel for the MRTs. The service support flight is responsible for first-line messing, accommodation, administration, transport, supply, and medical support. This flight is the principal organization for the provision of aircraft spares within the wing. The squadron's major equipment consists of approximately 75 vehicles, such as light vehicles, medium cargo vehicles, specially equipped vehicles, and recovery vehicles. It also has 2 sets of forward area refueling equipment. Specially equipped vehicles are the backbone of the squadron's maintenance capability. Each SEV is a specialized, self-contained shop which provides a mobile second-line repair and inspection facility and may, if required, be deployed as part of a MRT. In the event that buildings are not available, the squadron uses portable shelters to house aircraft undergoing extensive maintenance. It also incorporates a decontamination unit for operations in a nuclear or chemical environment. The squadron uses the area trunk system for the bulk of its communications, backed up by combat net radio for voice and message traffic. The maintenance squadron command net is used for all squadron communications, including control of MRT activities. Landline is used for local communications within the squadron's location. The squadron is normally located in the rear of the division administrative area. This location provides easier access to core support facilities and the relative degree of security required to conduct second-line maintenance. The squadron is on 6 hours' notice to move throughout its maintenance operations. The location must also permit access to wing headquarters and other aviation units. A typical field layout would have a landing zone and a parking area with shelters for attack, utility, and observation helicopter inspections, and for snag rectification. The squadron headquarters is sited in an area accessible to all subunits. SEVs are sited according to their function. The administrative area is separated from the work area, and the entire complex is laid out to provide all-around defense. The size and location of the landing zone are critical factors in the selection of a site due to the volume of air traffic and the number of test flights associated with supporting large numbers of aircraft, along with the requirement for tactical dispersal on the ground. The squadron is responsible for its own self-defense and must be prepared to fight and defend itself. The major technical tasks undertaken by the squadron are periodic and supplementary inspections, snag recovery, in situ repairs, maintenance control and records, and test flights. Periodic inspections, which ensure the continued airworthiness of aircraft, form a large share of the squadron workload. These are major maintenance activities which can take from days to weeks to complete and are carried out at predetermined intervals based on flying hours. Card decks, a form of checklist, act as a standards control and detail the specific inspection item. Much of the inspection is carried out on the aircraft. However, many components must be removed and passed to the specialized workshops for their detailed inspection and calibration. A variety of aircraft hardware and components, ranging from individual bolts in rotor assemblies to major items such as power plants, are assigned a service life based on flying hours. Items which have reached their authorized life are replaced during periodic inspections. Many items on an aircraft must be inspected and serviced at more frequent intervals than those specified in the periodic inspection schedules. These supplementary inspections typically include lubrication and oil filter changes, as well as wash procedures on the engine compressors. These inspections take only hours to complete and are scheduled to have minimal operational impact on the frontline squadrons. Ideally, the aircraft will be flown to their maintenance squadron location for their required supplementary inspections, returning to service within a few hours.
And what do we break today?
There are many components in an aircraft which have no predetermined life and which will fail in use. These components are either discovered during an inspection or reported by the air crews as snags. These unscheduled maintenance requirements entail the rectification of major snags, such as engine changes, intermediate snags, such as repair or replacement of radio or avionics equipment, and minor snags that first-line units cannot rectify due to lack of tooling, test equipment, or time. Rectification of major snags generally is carried out using shelter accommodation, while many intermediate and minor snags are repaired outdoors. Aircraft with defects which do not jeopardize their airworthiness are frequently flown to the maintenance squadron for repair. In instances where the aircraft cannot be flown due to the nature of the snag or weather, the wing headquarters tasks the maintenance squadron to dispatch a MRT. Team composition varies with the nature of the snag, estimated transportation requirements, and tactical considerations. Team members are drawn as required from all of the squadron's flights. The aircraft will be repaired on site or transported to a location where repairs can be accomplished. The Aircraft Maintenance Control and Records Office is separate from the Squadron Headquarters Maintenance Control Center. This office maintains the technical logs for all supported aircraft, prepares numerous reports and returns on behalf of the supported units, maintains a master technical library, and directs a comprehensive quality assurance program designed to monitor maintenance standards within the squadron. The office liaises with wing headquarters staff who analyze and assign priorities to ensure that the maintenance support requirements of all the wing's squadrons are integrated with division operational requirements. This liaison provides a smooth, steady flow of work into the maintenance squadron. Test flights are required to identify defects before and ensure airworthiness following a periodic inspection, as well as confirm airworthiness following many other maintenance activities. Maintenance test pilots are selected for their knowledge, experience, and expertise. They are invaluable links in diagnostic and adjustment procedures and are instrumental in returning the wing's aircraft to service in minimum time.
Yeah, that's a good engine.
The aviation units within the wing are tied into the divisional and brigade replenishment systems, and except for aircraft spares, are resupplied on the same basis as land force units. Wing units obtain their aviation spares from the maintenance squadron, which either satisfies their demands from within its own stock or obtains the required spares from core resources. Routine delivery of these spares is accomplished through delivery points. Priority delivery can be arranged by road or air. During peacetime, aircraft inspection and repair procedures are tempered by economic factors which dictate requirements beyond those concerned only with airworthiness and mission capability. Under these conditions, procedures are designed to cater to immediate requirements and also to ensure durability. The peacetime philosophy, which addresses the need to take full advantage of the fatigued life of aircraft, is not entirely appropriate for operations during wartime or during emergency conditions. In operations, the aircraft maintenance schedule is amended by deleting those inspection items which are not critical to flight safety or mission accomplishment. This action reduces the time required to complete the inspection, thereby providing the operational commander with the maximum number of aircraft. Whenever reduced activity permits, the maintenance schedules will return to peacetime standards and methods. Some aircraft will sustain battle damage during the conduct of a mission or on the ground. In some circumstances, operational requirements will dictate the use of rapid repair techniques, known as aircraft battle damage repair. The concept is based on the principles of simplicity and speed, and has the goal of ensuring an aircraft can fly at least one additional combat sortie with at least minimum mission capability. Although there are go, no-go guidelines for critical components, actual battle damage repair techniques are limited only by the experience and ingenuity of the technicians. If repairs cannot be accomplished within a reasonable time frame, The aircraft could be cannibalized, or, if the combat situation warrants, destroyed. The Wing Maintenance Squadron is designed to meet the second-line maintenance needs of aircraft dedicated to division operations. It is a key element in ensuring maximum aircraft sorties are available to the operational commander, and it provides a significant contribution to the success of the land battle.
Surveillance is the principal means by which enemy locations and activities are detected. Ground-level and aerial surveillance is aimed at acquiring continuous, systematic, coordinated, and timely information to support tactical ground operations. Surveillance involves maintaining a continuous watch over the battlefield. Like reconnaissance, which seeks out information on the enemy and on the ground, and target acquisition, which fixes the enemy, surveillance contributes to the development of the intelligence picture and provides a degree of battlefield security. In most cases, the surveillance plan will not require redeployment of forces. Surveillance responsibilities are based on a commander's area of influence. Commanders will rely on formations, units, or their flanks, and on their next superior commander for surveillance and warning out to their area of interest. Special attention must be paid at all levels to ensure no gaps appear either between boundaries or within their rear areas, and that all high-speed enemy approaches are covered. The combat surveillance system strives to make the most economical use of command and control procedures, equipment, and personnel. It integrates intelligence gathering, security, deception, reconnaissance, surveillance, and target acquisition plans and activities, and supports the combat intelligence system. The combat surveillance system aims at providing essential combat information to commanders to allow them sufficient time to react. The combat surveillance system incorporates an ADP capability to handle and quickly process the high volume of information received from surveillance, reconnaissance, and target acquisition sources. It produces hard intelligence, allowing for the exploitation of situations and targets. In addition, essential information is presented in a format that provides the commander with as much advanced threat warning as possible. In view of the nature of the information required, the activities of the combat surveillance system are grouped into area surveillance, reconnaissance in depth, reconnaissance and surveillance to line of sight, and target acquisition. Area surveillance provides up-to-date ground information on enemy deployments and activities and cues reconnaissance, surveillance, and target acquisition resources to provide detailed information. It also provides early warning and assists with the targeting of electronic warfare and indirect fire assets. Reconnaissance in depth provides detailed ground information beyond line of sight. It identifies the composition and locations of enemy forces, provides early warning, updates tactical information, and acquires targets for air and ground-based indirect fire weapon systems. Reconnaissance and surveillance to line of sight satisfies the requirement for detailed combat information and overlaps with the target acquisition function. Specialized target acquisition activities for direct and indirect fire weapons enables enemy assets to be identified and accurately located or fixed in sufficient detail to permit immediate attack, or to orient or cue other acquisition systems or intelligence gathering assets. The system makes the most efficient use of all available sources to collect information. These include non-specialized units, which incorporate a variety of weapon sights, laser rangefinders, night vision aids, and specialized organizations such as reconnaissance, target acquisition, observation, and electronic warfare units and subunits belonging to the division and certain core collectors and air defense assets. Advice, planning, and management of combat surveillance resources and agencies is carried out by the G2 staff and the Intelligence Collection and Analysis Center. The control of troops, the establishment of surveillance and target acquisition priorities, as well as the tasking and coordination of combat surveillance entities, are the responsibility of the G3 staff. The goal of managing combat surveillance resources is to ensure effective use of a limited number of assets against a large target array of enemy movers, shooters, sitters, and emitters. Planning for the combat surveillance system originates from estimates produced by the intelligence and operations staffs. These estimates eventually evolve into the Surveillance and Target Acquisition Annex and the Intelligence Annex to the Formation Operations Order. The Surveillance and Target Acquisition Plan is developed in concert with the needs of the Intelligence Collection Plan. It covers the employment of patrols, ground and air observation posts, listening posts, weapon locating radars, remotely piloted vehicles, electronic warfare intercept and direction finding devices, ground sensor systems, night illumination devices, and a variety of other systems and equipments which operate throughout the entire core area. It also details the emission control policy and the area of surveillance responsibility for the subordinate formations and units. In addition, this plan provides guidance to its subordinates and allows them to increase the degree of surveillance at certain times and at certain locations, depending on foreseen levels of enemy activity. The plan also provides combat information to meet the commander's critical intelligence requirements. The STA plan starts as an annex to the Core Operations Order. The plan is refined downwards, with division and brigade headquarters allocating resources and coordinating plans and activities, and with units implementing tasks within their specific area of responsibility. The process is never-ending and is continually adjusted, updated, or modified to meet specific needs. The plan aims at providing timely information to the level of command that can react, retaliate, attack, or otherwise take action. The plan takes into account deception, communications, anti-armor, patrol, electronic warfare, fire support, and other ongoing plans and activities. At division level, the ICAC, on behalf of the G2 staff, coordinates the integral intelligence collection assets, whether they be allocated to reconnaissance, surveillance, or target acquisition missions. Each level of command is responsible for the collection of information within its area of responsibility. The planning process takes into account the need to constitute a separate surveillance force, areas or locations which require particular surveillance, information provided by higher and adjacent formations, the use of deception to disguise surveillance activities, the allocation of resources, and the Corps and Division's emission control policies, which normally impose restrictions on the use of radars, active infrared sensors, and white light, so that the enemy will not be provided with information on our defensive layout. The battle group commander formulates his surveillance and target acquisition plan within the framework of the brigade plan. It integrates all battalion surveillance resources, as well as those of any attached organizations. The plan sets down control measures for active systems and white light operations, and details any special communications requirements. Control of all surveillance activities is normally held at the highest possible level, with command being decentralized to the units or subunits which operate the devices and have the means to react. At unit level, the intelligence officer coordinates surveillance activities throughout its area, from the rear boundary out to its area of influence. He also makes recommendations for deployment of STA assets to ensure maximum continuous coverage.
We've just had 2 sections move in and depth.
He maintains the unit surveillance map, which shows the location of the battalion's elements, surveillance equipment, OPs, and standing patrols, including their arcs of possible coverage, as well as dead ground and gaps, and the task of each deployed collector, adjacent units coverage of the unit area, limited visibility or night restrictions, patrol routes, and coverage by other collectors, such as artillery OPs and vehicle or helicopter patrols. Communications are the key to effective surveillance operations. They are required for the passage of advance information concerning enemy concentration and movement, for early warning, and for illumination requests. Transmission means include combat net radio, data link systems, and field phones. Net radio traffic dealing with surveillance activities may be carried on the unit command net, but could also be carried on a special surveillance net linking all observation posts, radars, patrols, and the like. A typical surveillance scenario might involve an OP maintaining watch over a portion of an important approach or route. The OP would be sighted for the maximum range of visibility in daylight. At night, the observer can extend the range of his night vision and would be assisted by remote sensors and flares. Any indication of activity would see the observer triggering active sensors and requesting illumination. Once the significance of a contact is confirmed, more vulnerable and sophisticated means of gathering information may be called upon, such as active patrolling or an air reconnaissance mission. In addition, the target could be attacked by fast air, artillery, EW, or other assets, including direct fire weapons. RPVs can be used to monitor the target reaction and provide information for post-strike analysis.
Moving northeast, heading northeast.
Battlefield surveillance and target acquisition resources generally include ground and air observation posts, patrols, stay-behind parties, reconnaissance troops, fire controllers, and artillery OP parties. These personnel generally use viewing devices to improve their observation in bad light and at night. They also use warning devices, which attract their attention to areas outside their arc of direct observation. Individual weapon sights for use at night and in conditions of poor visibility. White light from searchlights, flares, or shells, which improves night viewing conditions. Weapons locating radars and surveillance radars, which can detect moving targets and distinguish between men and vehicles. Sensors which warn of intruders in dead ground. RPVs and drones, which provide reconnaissance and target acquisition information. Electronic warfare devices, which can detect, locate, and provide information from enemy transmissions. And sound ranging equipment, which can locate enemy guns. Counter-surveillance activities include ways by which the defender can seek to avoid detection. These involve avoiding the enemy's routine areas of surveillance, the effective use of camouflage, keeping movement to a minimum, using deception, and treating night as day and using the same countermeasures at all times. A well-managed combat surveillance system will go a long way in providing the required combat information and intelligence needed for the planning and conduct of operations. A vital step in meeting this need is the ongoing process involved in surveillance and target acquisition planning.
Weather exerts a definite and at times a decisive influence on military operations. To best exploit the tactical advantage which may be afforded by favorable weather, and to minimize the disadvantages of unfavorable weather, commanders are advised by the Combat Meteorological Organization of past trends, present, and anticipated weather conditions. It coordinates the activities of Met elements deployed at key headquarters and locations in support of the operational requirement. The Corps Combat Meteorological Organization provides a detailed knowledge of surface and upper air conditions, actual and forecast, in the volume of the atmosphere covering the Corps. This also includes a sizable portion on the enemy side of the forward line of its own troops. As new munitions are acquired, the requirement for Met information changes. For example, the height of the cloud base and horizontal visibility may affect the maneuverability dimensions of the munition and its ability to strike the target. The determination of the cloud base and visibility become critical factors in the effectiveness of these weapon systems, as well as for air support to operations. Wind, air density, and other parameters of ballistic meteorology affect weapon accuracy. For example, weapon systems engaging targets at ranges in excess of 2,000 meters require crosswind speeds to be computed within 1 knot to ensure a first-shot kill. Trafficability, counter-mobility efforts, and natural obstacles are seriously affected by weather. Aviation, tactical air operations, rappelling, and parachute operations can also be hindered by inclement weather. Consideration of the effects of adverse weather must be incorporated into operational planning to ensure equipment, individual clothing, ration scales, cover, concealment, nuclear and chemical defense measures are adapted to the prevailing Met conditions. Weather will influence the tactical command, control, and information systems placed at the disposal of various commanders. Replenishment and maintenance within the Corps will be greatly affected by weather, involving changes to consumption rates of combat supplies, increased vehicle maintenance, and the overall deterioration of weapons and equipment effectiveness. Through the G2 staff, the organization provides meteorological information from the Corps rear area through to the forward edge of the battle area, forward throughout the covering force area, and in depth extending to the enemy's second echelon. It does this by taking high-level soundings to over a radius of 30 kilometers, low-level soundings on a 15-kilometer grid, and surface observations on a 5-kilometer grid. The organization also collects and collates weather reports sent by artillery observations officers, forward air controllers, and others. The Corps Combat Meteorology Organization consists of a small headquarters, a meteorological collection and analysis center, a ballistic Met troop, and an aviation Met troop. These elements are sufficient to satisfy both the technical and operational aspects of weather intelligence.
Okay, our people will be ordered right away.
The senior Met officer is the Met advisor to the Corps commander. His small staff operates from the Corps main headquarters location. There he provides, in conjunction with the Corps Intelligence Collection and Analysis Center, inputs to the theater-wide meteorological system which are required for strategic planning purposes, advice to the Corps staff, liaison with Army and theater Met services, and implements arrangements for data sharing with other theater agencies. In short, the senior Met officer and his staff coordinate the overall Met efforts within the Corps.
Yes, this is a second aviation...
Also located in close proximity to the Corps main headquarters is the Corps Integral Field Forecast Center, which is designated the Meteorological Collection and Analysis Center. It provides general and specialized weather forecasts, weather warnings and briefings for all phases and aspects of Corps operations. Products include METRAPs, NBC Met Messages, fire weather indices, aviation weather, and natural light data. To look after artillery Met requirements, a ballistic Met troop is provided to Corps Artillery. It includes a headquarters element located with the Corps Artillery headquarters, and a ballistic Met section which is assigned to each division. The headquarters advises the Corps Artillery staff on the distribution and employment of ballistic Met resources, provides expert advice on ballistic Met matters, and coordinates the technical aspects of logistic support for its own specialized equipments and expendables. It also conducts liaison with the Meteorological Collection and Analysis Center on the Corps' other requirements for upper air data, and ensures the provision of Met information and forecasts necessary for the efficient employment of artillery drones, remotely piloted vehicles, and air defense resources.
Charlie 1, this is 0. Whole group at this location at 1400 hours today, over.
The Division Ballistic Met Section is located at Division Artillery Headquarters, where it provides ballistic Met advice to the Commander Division Artillery. Its resources include a radiosonde detachment, that sounds the upper atmosphere, measuring temperatures, pressures, relative humidities, wind direction and speed, thus providing scientific data for weather forecasting and crucial ballistics data for indirect fire weapons. The section also deploys mini-sonde detachments, which sound the lower atmosphere and provide surface weather observations. These detachments help meet the technical requirements of the Corps Met Grid and tactical requirements of the Division Operations Plan. Aviation meteorological requirements are satisfied by the Corps Aviation Met Troop, which is organic to Corps Aviation. The troop is organized into a headquarters, 3 wing Met sections, and a Met detachment for each Corps Aviation squadron. The headquarters is co-located with the Aviation Group headquarters and provides advice to the Tactical Aviation Group commander and his staff on meteorological matters. It also functions as a Met detachment in the Corps grid, providing surface weather observations. The Wing Met section is located at the Aviation Wing headquarters and is organized into a headquarters with its associated Met detachment and a Met detachment for each of the wing squadrons. The headquarters coordinates and disseminates the required meteorological information to the Wing's aviation units and provides the Division Intelligence Collection and Analysis Center with its Met representatives. In addition, it tailors weather forecasts pertaining to the divisional area, provides briefings to the Wing staff, and transmits weather information. Its detachments conduct squadron briefings, take surface observations, and input their acquired data into the meteorological information system. The Corps complement of Met personnel totals approximately 160 all ranks. Its equipment includes approximately 20 MLVWs, 50 1¼ vans, and 10 1/4-ton vehicles. The MLVWs are used as operation centers to collect and collate data and provide weather briefings for artillery radio sonding, operations, and for resupply. The 1¼ ton vans are used for communications and mini-sonde operations. The 1/4-ton vehicles are used for reconnaissance, communication, and liaison. Specialized Met equipments include high-level radio sondes which provide Met data to altitudes of 20 kilometers. These are tracked by a passive radio direction finder, which relays the received signal to a pair of recorders. The atmosphere's vertical profile is then plotted for display on different forms and diagrams. Low-level mini-sondes provide temperature-only data to an altitude of 3 kilometers. The balloon in flight is tracked optically to obtain winds aloft. RPV Met sensors of the target acquisition battery function similarly to the mini-sonde, except that they are employed near the surface. Handheld laser ceilometers are used to measure cloud heights. Surface measurement instruments are used by Met detachments to monitor weather conditions. And portable terminals receive and transmit Met data as an outstation on the Tactical Command, Control, and Information System. The meteorological system is essentially an information-gathering organization, set up on a theater basis. The Corps and Division entities provide the bulk of the raw data. Raw data is passed from the Met elements via data links directly into the Corps data bank, where it is retrieved by the MCAC, collated, analyzed, and used in the production of weather forecasts, and redistributed downwards as Met intelligence. This MET intelligence is stored and disseminated by the Combat Information System through the Corps and Division ICACs and the Corps MCAC. Major users of MET data are the command staffs, the guns, and aviation units, all of which have specialized MET resources deployed in key locations. The meteorological intelligence provided by the Combat Meteorological Organization forms a basic building block in the Corps information requirement. It is critical to the activities of artillery and aviation units, and is required by staffs at all levels involved in the planning and directing of operations.
The division headquarters is responsible for the planning, direction, and coordination of division combat operations, including the collection, collation, and analysis of information, and the dissemination of intelligence, the direction of active electronic warfare support, the coordination of artillery, air defense fire, and close air support, the coordination of combat engineer and tactical aviation operations, and for combat service support activities. The Div HQ is too large and too vulnerable to be grouped in one location. It is therefore divided into a Div main, a Div alternate, and a Div rear headquarters. Communications and support are provided by the Division Headquarters and Signals Regiment. Located at Division Main Headquarters are the Commander and the Chief of Staff, the Intelligence and Operations Staffs, selected Arms, Aviation, and Air Advisors, and an Administration Coordination Staff. The headquarters is supported by the Division Main Headquarters and Signals Squadron, which provides the communications, administration, and defense of the headquarters. The Div Main HQ covers the better part of a grid square and usually deploys off a main route in a wood, town, or village. It is sited to provide for good communications, concealment, access to routes forward, and a degree of security which permits the staff to work relatively unhindered.
612, roger out.
The operations area is the core of the headquarters complex. It contains an operations center, intelligence center, fire support coordination center, various arms, air, and aviation cells, an administration coordination cell, a plans cell, a communications access facility, and may include the Intelligence Collection and Analysis Center. Surrounding the operations area are other communications elements, administrative support elements, and living areas. An information post is located at the en route, and pickets, security patrols, and surveillance detachments provide for the perimeter defense of the area. The main headquarters may be moved as the situation demands. A simple move takes approximately 6 hours, not counting traveling time. The Tactical Command Post is a small element drawn from the Div Main HQ structure. It consists of a protection party, the Division Rover Group, Command Post APCs with staff officers, and an Area Trunk Communications Detachment. It deploys well forward of Div Main with a minimum of equipment.
1, 2, 3, left.
The TAC CP enables the commander and a highly mobile staff group to exercise closer personal control over the battle. The TAC CP generally remains on 2 hours' notice to move and can operate independently for up to 48 hours. The division alternate headquarters ensures the continuity of control when the division main headquarters is on the move or threatened by enemy attack. It is a separate facility containing the equipment and staff to maintain control until it is reinforced or until the main HQ reestablishes itself in a new location. The headquarters avoids detection by maintaining radio silence whenever possible. Also in location is the designated alternate division artillery headquarters. Div alternate HQ mirrors the activity of the main HQ and incorporates intelligence, operations and services cells and arms advisors. It is sited similarly to the main HQ, with its communications, local administration and defense provided by the Div Alternate Headquarters and Signals Squadron. Division Rear Headquarters is responsible for coordinating the combat service support needs of the division. It detaches an administration coordination cell to Div Main HQ to assist with the administrative aspects of ongoing and future operations. The Div Rear HQ is located in the division administrative area and may be up to 30 kilometers from the Div Main HQ. The Division Rear Headquarters and Signals Squadron provides the required communication facilities and personnel for local administration of this headquarters. The commander and his staff maintain effective command and control of the division's elements and operations through the use of the Automated Combat Information System, the Area Trunk Communications System, Combat Net Radio, the Signals Dispatch Service, a local intercommunication system, and through liaison officers. The Division Chief of Staff heads up the G2 and G3 staffs and is the senior headquarters staff officer responsible for the direction and coordination of all staff activity. He helps the commander with decision-making and in directing and coordinating the execution of plans and orders. The Division G3 staff assists the commander in planning, directing, controlling, and coordinating division operations. The staff is organized into operations, plans, staff duties, NBC, liaison, and provost marshal cells. The G3 is the Chief of Staff's deputy. He understudies the Chief of Staff and assumes his responsibilities as necessary. He is responsible for the detailed coordination and direction of the G3 staff activities, including determination of intelligence requirements, estimates and casualty forecasts, preparation of operation orders and instructions, execution of operations, coordination of headquarters activities with the arms staff and other agencies, and release of controlled stores. The G3 operations understudies the G3 and will assume his responsibilities when required. He is responsible for overseeing the functions of LOs and staff advisors, directing headquarters moves and the defense of the operations area, liaison with other formations, and providing information on the combat capability of the division. G3 Plans is responsible for maintaining, controlling, and distributing all operational plans, and assists in writing plans, orders, and estimates. G3 Staff Duties looks after tables of organization and equipment, terrain control, and coordination of moves and deployment. The G3 Nuclear, Biological, and Chemical Operations is responsible for NBC plans, operations, and advice, predictions and measurement of contamination, and allotment of NBC resources. The division liaison officers represent the division commander's intentions and interests at various locations. The senior LO normally represents the commander at Corps headquarters. He coordinates the LO rosters and ensures the LOs are well administered and understand their duties. The division provost marshal is located at the main HQ and is responsible to the G3 for traffic control planning and advice on military, police, and traffic matters. He also provides a small cell to the Div Rear HQ G1 staff, which assists with discipline and criminal investigations, punishment facilities, and PWs, stragglers, and refugees. The G2 staff provides the commander with the intelligence required to plan and conduct operations. This involves the timely estimate of the enemy's location, activities, capabilities, and intentions. The Division G2 is responsible to the Chief of Staff for the detailed activities of his section. Specifically, he is responsible for intelligence estimates and liaison, planning the conduct of counterintelligence operations, the intelligence collection, surveillance, and target acquisition plans, coordinating recce requests, analysis of all information, disseminating intelligence, meteorological, and terrain information, distributing maps, geographic information, air photos, and code words and nicknames, assisting in the preparation of the deception plan, and providing advice on PWs, ECM, and ECCM. His staff breaks down into an operations cell, an estimates cell, and a special material control cell. The G2 operations supervises the G2 duty staff in the division main CP. He effects liaison and coordination with the other staff sections, the main CP, and with the intelligence company. He works closely with the G3 Ops and the FSCC, and is primarily concerned with priority intelligence support to current operations. G2 Estimates is responsible for the production of intelligence estimates and for support to future operations. In this position, he works closely with G3 Plans. The Administration Coordination Cell is provided from the resources of the Assistant Chief of Staff Administration at Div Rear HQ and is detached to the Division Main HQ. It provides the main HQ operations staff with combat service support advice on current operations and keeps the ACOS ADAM informed on pending activity. The headquarters of the Commander Division Artillery is located near the Div Main HQ. The CDA advises the division commander on all artillery matters and provides the resources to establish the Division Fire Support Coordination Center.
All guns will be under command of the CDA.
The Fire Support Coordination Center is directed by the G3 Artillery Operations. It is co-located with the Div Main HQ Operations Center. The FSCC provides advice on the use of all fire support resources. It plans and coordinates fire support, air defense, and airspace control within the division, and allots fire support resources to meet the commander's plan. Communications links are provided from the FSCC to all available fire support agencies by the Division Headquarters and Signals Regiment. The Aviation Cell functions under the Commander Division Aviation. It provides advice on the use of assigned and available aviation resources and coordinates aviation support to the division. The Air Cell is manned from the supporting Air Force Tactical Air Control Party, headed by the Division Air Liaison Officer. It handles requests for close air support missions and provides advice to the staff on offensive air support matters. The Signals Cell is headed by the Commander Division Signals, who coordinates the activities of the Headquarters and Signals Regiment. The Division Operations Staff ensures that the cell is kept informed of the operational situation and of its staff requirements. The Commander Division Engineers advises the Commander on all engineer matters. He maintains a permanent engineer liaison detachment at Division Main Headquarters, which ensures continuous engineer information is available to the division staff. The detachment's responsibilities include coordinating staff work with Div HQ staff on barrier plans, execution of preliminary and reserve demolitions, employment of scatterable mines, and terrain control for engineer units, maintaining accurate records of engineer work and keeping Div HQ staff informed, and ensuring Headquarters CDE is kept advised of all requests for engineer assistance. Division Rear Headquarters is commanded by the Assistant Chief of Staff Administration and consists of the G1, G4, and G5 staffs, specialist staff, and services advisors. The ACOS Adam is responsible to the division commander through the Chief of Staff for organizing, directing, and supervising the division administration staff. He assists the Chief of Staff by drafting administrative plans and orders, and in directing and coordinating their execution. He keeps the Commander and Chief of Staff advised of combat service support considerations which could affect operations. The G1 staff assists in the personnel administration of the division, particularly with manning, and the employment, discipline, and well-being of the soldier. The G1 staff includes the G1 Personnel Administration, Division Surgeon, G1 Dental, Division Assistant Judge Advocate General, Senior Chaplains, and the Public Information Officer. The G1 Personnel Administration Cell is responsible for personnel management and services, which include manpower allocation, personnel evaluations, promotions, postings, replacements, personnel records, investigations, service discipline, redresses, casualty reporting, honors and awards, graves registration, recreation and leave, institutes and amenities, pay and postal activities, PWs and stragglers. The division surgeon provides medical advice, develops policy and plans on medical treatment and evacuation, and coordinates the employment of division medical resources. G1 Dental is responsible for providing advice, determining priorities for dental care and treatment, and coordinating employment of division dental resources. The Assistant Judge Advocate General advises the Commander on Geneva Convention's requirements relating to targeting objectives and weapons types, treatment of PWs and civilians, discipline, and administrative procedures. In addition, he and his staff provide advice to commanding officers and to the troops on disciplinary, administrative, and legal matters. The division senior chaplains provide advice, coordinate chaplain resources and administration, and supervise all ecclesiastical matters. The public information staff is responsible for advising on public information activities, establishing security measures which relate to the dissemination of information, operating a public information center, arranging for military escort and accreditations of the media, and preparing news releases for the troops. The G4 staff assist the commander with arrangements for the logistics aspects of combat service support, specifically supplies, accommodation, maintenance, and administrative movement. The G4 staff are subdivided into operations, supply, transport, and maintenance cells. The G4 is the ACOS Adams deputy and is responsible for administrative estimates, orders, and instructions, advising the G3 on provision of additional logistic resources, logistic installation and unit locations, grouping and employment of logistic elements, and arranging the acquisition of material and services from local resources through the G5. The G4 operations staff is generally responsible for developing administrative orders, instructions, policies, and directives, preparing logistics estimates, obtaining additional logistic support, providing specialist advice, coordinating locations for logistic units as well as their employment, deployment, and grouping, coordinating the operation of commodity points, developing the administrative portion of the division SOPs, and coordinating G4 staff activity. G4 Supply is involved in planning, coordinating, and controlling the provision of supply and decontamination services to the division, controlling the issue of material in short supply, coordinating the issue of controlled stores on direction of the G3, and supply policy and advice to units. G4 Transport is responsible for planning and coordinating all transportation resources, planning and coordinating administrative movement, directing and coordinating movement control services and facilities, and providing advice and technical control of transportation activities in subordinate units and formations. The G4 maintenance duties encompass planning, coordinating, and controlling maintenance activities, developing repair parts scaling, directing, coordinating, and disseminating technical corrective measures and information, and providing maintenance policy, technical direction, and advice to units and formations. The Artillery G1, G4 staff from Division Artillery Headquarters is located at Div Rear HQ. Its primary concerns center on the replenishment and maintenance of the division's artillery units and on ammunition resupply. An Engineer G4 representative from Headquarters CDE is also located at Div Rear HQ. He is primarily concerned with the provision and flow of special stores and equipment to the division engineer units. The G5 staff breaks down into an operations cell and a plans cell. These cells assist the commander in the development and execution of policies relating to local national authorities and the civilian population. G5 responsibilities may include preparing civic estimates and the civic portions of administrative plans and orders, assisting in establishing military government agencies when required, and assisting other staff branches in dealing with national authorities and the civilian population. They may also deal with population movement control, refugees, rear area security, and particularly damage control problems, coordinating mutual engineering and logistics assistance, and procurements of local accommodation and material. One of the tactical command, control, and information systems placed at the disposal of the staff is the Automated Combat Information System. The ACIS receives information and intelligence from a variety of sources, which can be recalled, displayed, updated, and disseminated to commanders and their staffs. Once decisions are taken, the system is used to issue directions, monitor feedback, and to control operations. The ACIS is made up of operations, intelligence, fire support, air defense and airspace control, and administrative subsystems. Each subsystem is interconnected to allow the sharing of data and exchange of information by division main, alternate, and rear headquarters, and by other division elements, subordinate units, and formations. The ACIS functions on secure data links. It is integrated into the area trunk system and has access security in the software and at the terminals. The operations subsystem incorporates user terminals for the various commanders and their staffs. Information is displayed for review by the duty officer, who evaluates, stores, updates, and distributes it as appropriate. The intelligence subsystem allows rapid access by intelligence staffs at all formation headquarters to stored information, with sorting, collation, and extrapolation to suggest possible trends. It receives information from the intelligence cells, sources, and sensors, recce units, the FSCC, the EWCC, and from maneuver formations and units. This information must be evaluated, coordinated, and entered into the database. In addition, the G2 can display urgent information on terminals of other subsystems. The fire support subsystem parallels the artillery command and control system and is used by the FSCC to assist in detailed fire planning, coordination of fire support, and to optimize the use of resources. It integrates the wide range of direct, indirect, air, and aviation fire support resources. The terminals are capable of specific fire support data manipulations and are located at FSCCs at all levels. The Air Defense and Airspace Control subsystem inputs data from radars, sensors, and various headquarters terminals. It integrates the air defense systems with artillery, air, and aviation resources. The administrative subsystem allows the G1, G4, and G5 staffs to manipulate their data. User terminals are located at all administrative installations and headquarters. The division is the basic combat formation on the battlefield. Its diversified staff and various advisors provide the advice and assistance to coordinate and control ongoing operations. The division headquarters is structured so that the commander can operate well forward and be personally involved in the battlefield direction of his combat elements.
During a withdrawal, demolitions play an important role in delaying the enemy, particularly at locations where crossing areas are limited. Demolitions are a unique form of an obstacle, which have the important advantage of not being effective until fired. The importance of demolitions to barrier and maneuver planning requires commanders to exercise considerable control over their emplacement, guarding, and firing. The enemy will often find it advantageous to interfere with our obstacle and barrier plans, either by seizing crossings for his own use, or by causing the premature firing of demolitions so as to prevent our forces from withdrawing or carrying out counter moves. Although engineers usually prepare and fire the demolitions, commanders remain responsible for the security of the demolition and the control of their firing.
No, I think the first part is good. And I think the
demolitions are classified as preliminary or reserve targets. Preliminary demolition targets are those which do not interfere with our planned tactical movement and are executed soon after preparation, provided prior authority has been granted. Targets include craters, bridges, culverts, hill cuts, trees, and buildings. They are fired on the orders of the officer to whom the responsibility has been delegated. Reserve demolition targets are specifically controlled demolitions based on terrain features. They play a vital part in the tactical plan and must initially be denied to the enemy. Reserve demolition targets are selected by corps, division, and sometimes by brigade commanders, and generally include bridges, minefield lanes, and the like. They often affect movement along a reserved route. The Corps and Division Engineer Commanders advise on the technical aspects of a demolition, including an estimate of time and resources required to develop it and the expected results. They assign an engineer unit to prepare the target, to provide the demolition firing party, and to secure the target until the guard arrives on site.
Okay, so let's look at the 913 and go through some of the procedures.
The demolition order is the only document to be used to control the firing of a reserve demolition.
And of course,
It provides the orders for the demolition guard commander. The order may also be used to direct the firing of a preliminary demolition in situations requiring control for political or tactical reasons. Instructions pertaining to the target are printed on the reverse of the form and are to be followed exactly. Copies are distributed to those appointments directly involved in the task. A demolition is charged when the explosives have been emplaced either in a State 1 safe or a State 2 armed condition. In the safe state, the charges and firing circuits have been installed. However, the detonators are not connected. In the armed state, all connections are completed and the demolition is ready for immediate firing. The length of time required to change the demolition from a safe to an armed condition is determined by the firing party commander and advised to the commander of the demolition guard and then made known to the authorized commander. The three commanders concerned with the firing of a reserve demolition are the authorized commander, the commander of the demolition guard, and the commander of the demolition firing party. The authorized commander is usually the formation commander in whose sector the demolition is located. He classifies the target and his staff prepare and issue the demolition order. The authorized commander is the only person empowered to order the firing of the demolition. He may delegate his responsibility to a subordinate commander who then becomes the new authorized commander.
I want to see those things popping as they approach.
The demolition guard commander commands all troops at the engineer demolition site, including the demolition firing party. He must ensure that the demolition is not sabotaged or captured by the enemy before it has been fired. He gives the order to change the state of readiness of the demolition and transmits the order to fire to the demolition firing party. He also keeps the authorized commander informed of the situation at the demolition site and reports to him on the effectiveness of the firing of the demolition. The engineer commander of the demolition firing party is responsible for the technical aspects of the demolition. He maintains the required state of readiness, fires the demolition when ordered, and ensures its firing is successful. The authorized commander must ensure that there is a clear-cut channel whereby he can pass orders to the commander of the demolition firing party. This channel is normally through the demolition guard commander, who receives his orders by a combination of means, principally involving normal command channels, an on-site liaison officer with dedicated communications, and artillery communications to an OP shared with the demolition guard commander. Orders may also be given on the spot by the authorized commander. It is normal for the authorized commander to send a liaison officer to the demolition site.
first thing we should do is make sure we got...
On receipt of the appropriate instruction, the LO orders the guard commander to fire the demolition and can report on the effectiveness of the firing. In most respects, a reserve demolition guard operation is a high-intensity defensive operation of limited duration. Battle group commanders are tasked to provide guards to ensure that demolitions do not fall prematurely to the enemy and to ensure that engineer firing parties are able to complete their task. These guards are normally a platoon or company strength with some support weapons, armor, and air defense weapons. In areas where refugees or civil traffic may be a concern, a military police organization would also be in support, as might be some CIMIC elements. The Reserve Demolition Defensive Plan must provide for adequate cover of the most likely enemy approach and for the security of the flanks and the rear of the position. The Demolition Guard commander ensures that his force is deployed to give close all-round protection to the demolition and to protect the engineer firing party. The sighting of section positions, support weapons, and armor is more difficult than normal, with the problem being compounded, especially if the site is directly overlooked by higher ground. Normally, the high ground that dominates the site should not be occupied at the expense of securing the immediate area of the demolition. Likely enemy aircraft approaches and potential close-in helicopter landing zones are covered by air defense elements and a designated mobile reserve. Other essential considerations include forward observation officers and infantry fire controllers must maintain observation over likely approaches and probable nearby helicopter LZs. The fire plan should incorporate illumination points. Surveillance devices should be deployed on the enemy side of the demolition. There must be a plan for the fighting withdrawal of elements of the guard from the enemy side of the demolition. In conditions of reduced visibility, positions should be adjusted to avoid infiltration. A small mobile reserve must be formed to reinforce, to counterattack, or to block an enemy air assault landing. At least one section should be given the task of guarding the demolition. Checkpoints have to be established to identify and control all movement across the reserve demolition. A refugee checkpoint must be established on the enemy side, and refugees and civil traffic should be diverted from the demolition or at least searched prior to crossing. Arrangements must be made for evacuating all elements of the demolition guard to the home side just before the demolition is fired, and a recovery vehicle should be located on the home side to keep the passage clear of any stalled vehicles. The guard command post is located on the home side of the obstacle in full view of the demolition and from where the demolition guard commander can best organize the defense of the site and remain in direct contact with the firing party commander. Within the command post, no radios should be within 3 meters of any firing circuit. The firing point location is selected by the demolition guard commander and is normally sited within or adjacent to the command post. The firing point must provide the demolition firing party with a view over the entire target area, yet be located close enough to allow them to easily maintain the demolition and to quickly change the state of readiness. It should not be more than 200 meters from the charges to keep the resistance in the firing cable to the minimum and to assist with the routine checking of the circuits. It should also be at least 30 meters from the road to avoid the risk of high-powered radars and radios from passing traffic from accidentally initiating the electric circuits. Alternate locations for both the command post and the firing point must be included in the defensive layout. One site should be located on the enemy side of the obstacle to counter any attack from the rear. It is normal for a withdrawing unit to position a liaison officer at the checkpoint. His task is to report when his unit has passed through and to identify any enemy infiltration attempt which may involve the use of captured vehicles, uniforms, and identification. The normal sequence for firing of a demolition is as follows. The Demolition Guard Commander reports to the authorized commander that demolition is prepared to State 1 and provides an estimate of the time required to change to State 2. The authorized commander orders a change to State 2. The Demolition Guard Commander completes the applicable paragraphs of the DND 913. The authorized commander orders the firing of the demolition. The Demolition Guard Commander orders the Demolition Firing Party Commander to fire the demolition by signing paragraph 13 of the demolition order.
It's been signed.
The commander of the demolition party fires the demolition, checks to ensure its success, takes any required action, and reports to the Demolition Guard Commander. The Demolition Guard Commander reports the result to the authorized commander and, when ready, withdraws his force and departs. The mission of the Demolition Guard is a most critical one. Premature destruction of the demolition may mean that great numbers of our own troops would fall into enemy hands. If the site falls intact to the enemy, a withdrawal could become a rout. The responsibility for the success or failure of the operation is that of the Demolition Guard Commander and his alone.
The Division Service Group provides second-line combat service support, less medical and military police services to formations and units of the division, and first-line support to division troops and units lacking self-sufficiency. The Division Service Group consists of a headquarters and signal squadron, 3 brigade service battalions, a transportation battalion, a supply battalion, a maintenance battalion, a field dental company, and a finance company. This presentation will not include details of the dental or finance companies, as they are covered in accompanying productions. The disc group total strength is approximately 5,900, all ranks, including more than 300 officers. Except for the medical and military police elements, the disc group commander is responsible for the command and control of second-line combat service support resources of the division. He provides advice to the division commander and implements the disc group portion of the division administrative plan. He commands for defense and movement, all units in the division administrative area, and is responsible for the division's rear area security and damage control operations. The tasks of the Disc Group headquarters include planning and supervising the execution of the Disc Group administrative plan, issuing orders, instructions, and directives, exercising technical control of Disc Group units, liaison with the division staff and other formations and units, coordinating and monitoring administrative reports and returns, controlling and coordinating the division's combat service support, security and damage control operations in the division rear area, and manning the Disc Group Operations Center. The headquarters is organized into G3 and G4 divisions. The G3 division is responsible for the coordination of all activities and the conduct of ongoing service support operations. It is divided into G2, G3 logistics operations, and G3 rear area security and damage control sections. The G2 section is responsible for the collection, compilation, interpretation, and distribution of intelligence information affecting the Disc Group. The G2 provides major input to rear area security and damage control plans and operations, and keeps the commander informed of developments in the overall intelligence situation. The G3 Logistics Operations section is responsible for conducting the day-to-day Disc Group activity and supervising the Operations Center, the Planning Cell, and the headquarters liaison detachments. The G3 Rear Area Security and Damage Control section is responsible for planning, command and control, and coordination activities for rear area security and damage control operations.
Planning van.
The G4 division is responsible for the internal administration of Disc Group and to assist G3 with the detailed planning for the Disc Group portion of the division support plan. The functional G4 staffs are responsible for administrative planning in the areas of transportation, supply, and maintenance. Also included are G1 and G5 staffs, who are responsible for personnel administration and civil-military cooperation. The Disc Group headquarters and signal squadron provides communication support for the Disc Group HQ and its functional battalions, and first-line administrative support to the HQ and any co-located finance and dental elements. The squadron consists of a headquarters, a radio troop, an access troop, a defense and security platoon, and a support troop. Operating from the Disc Group HQ location, the squadron provides an access node on the area trunk system, internal headquarters communications, and rear link combat net radio detachments on the core administrative data net, the Disc Group command net, and the division command net. A dispatch rider service also supplies communication services to the subordinate units of the Disc Group as required. To facilitate the command and control of all agencies supporting the battle, the combat service support formations, units, and elements are distributed throughout various administrative areas. These areas are formed to coordinate the defense of combat service support elements, to reduce the amount of administrative traffic, to simplify communications, and to provide a reception area for personnel replacements and material. Administrative areas require sites suitable for communications, good access to the main supply route, space for dispersion, concealment, accommodation, and hard standings. Areas are allocated to give the units maximum security and to allow them to work without frequent interruptions. Manpower for self-defense is kept to the minimum by sighting units, whenever possible in close proximity to the reserve troops. These administrative areas are broken down into division, brigade, and forward administrative areas.
Good, thank you very much. We'll see you out in the...
The division administrative area is commanded by the disc group commander and generally contains the combat service support resources which support the division. Composition of the DAA is not fixed, but normally includes disc group headquarters and signal squadron, transportation battalion, supply battalion, maintenance battalion, and elements of the division medical group and MP company. Additional organizations which may be located in the DAA are brigade administrative areas, aviation units, corps units, and division troop units. The location of the brigade administrative area depends on the tactical situation and the availability of terrain in the forward area. The composition is not fixed, but would normally include the disc group service battalion, Unit B echelons, elements of the field ambulance, military police platoon, and affiliated brigade aviation squadrons. If it is necessary to deploy combat service support elements well forward, portions of the service battalion, field ambulance, military police platoon, and Unit A echelons may form a forward logistics group located within a forward administrative area. This area allows elements to respond to the brigade's immediate combat support requirements while leaving the bulk of the support organizations further to the rear. The disc group service battalion provides second-line combat service support, less the military, police, and medical services, to its affiliated brigade from a location in the BAA. It is organized into a headquarters, which includes a logistics operations center and a signal troop, supply and transport company, maintenance company, and an administrative platoon. The signal troop, in addition to internal communications within the headquarters, provides the following: access node to area trunk system, rear link detachments for dispersed companies and for a forward logistics group, should one be deployed, and a signals dispatch rider service. Each battalion is established at about 30 officers and 600 non-commissioned members. Its equipment includes approximately 290 wheeled and tracked vehicles. The supply and transport company's 2 transport platoons each contain 20 tasked vehicles which carry and deliver the brigade maintenance load of combat supplies. Each platoon includes its own first-line support and can operate independently. The supply platoon processes demands for combat supplies, repair parts, and general stores for the brigade units and carries a limited range of these commodities. The Supply and Transport Company headquarters functions as the alternate service battalion headquarters. The maintenance company's medium and heavy mobile repair platoons provide wheeled and tracked mobile repair teams, which carry out in situ repairs in forward areas. They have a limited capability to recover vehicle casualties. The workshop platoon includes MRTs, which can repair electronic equipments, weapon systems, and can provide ancillary services. Its repair parts platoon carries a 15-day limited range of spare parts. The Transportation Battalion provides second-line transportation and replenishment support to the division, including carrying the division maintenance load of combat supplies, less that held by the disc group service battalions, replenishing division troops, operating limited general purpose transport, providing tactical air movement teams and postal services. The battalion consists of a headquarters, an administration company, general transport company, 2 ammunition transport companies, a movements platoon, postal platoon, and a combat supplies platoon. The battalion comprises approximately 1,240 all ranks. Total vehicles number approximately 650. This functional battalion can operate from the DAA in its entirety, or can be tasked to provide a slice of resources to a brigade service battalion or division troop units. The Transport Battalion Headquarters acts as the alternate Disc Group HQ and is co-located with and administered by its administration company. It includes the Transportation Operations Center, which controls battalion transportation activities. The administration company provides first-line service support to the battalion, including maintenance, quartermaster, personnel administration, medical, messing, military police, and security services. The General Transport Company handles that portion of the division maintenance load, less artillery ammunition, not carried by the Disc Group service battalions. It includes 105 task vehicles. The company delivers combat supplies to division troops and augments the Disc Group service battalions when required. The 2 ammunition transport companies carry and deliver the division maintenance load of artillery ammunition. Each company has 150 task vehicles for a total of 300 second-line artillery ammunition vehicles.
What we'll do for the vehicle marshalling is initially...
The movements platoon provides movement technical advice, teams for transfer points and terminal operations, a surface and air forwarding service, equipment and personnel for division airdrop and landing zones. It also trains helicopter loading teams and inspects aerial delivery equipment. The Combat Supplies Platoon incorporates 3 accounting teams, which account and arrange for the replenishment of all combat supplies comprising the division maintenance load. Each team is co-located with a transport company. The Postal Platoon provides postal services to brigades and to division troops. It offers specialist guidance and direction to unit postal clerks. The platoon is co-located with the headquarters of the General Transport Company. The Supply Battalion provides the division's input to the supply aspect of the replenishment system. The battalion has the responsibility to procure, account for, issue, and receive stores for the division, including combat supplies, repair parts, amenities, and general and technical stores. The Supply Battalion consists of a headquarters, an administration company, a repair parts company, a stores company, and a laundry, bath, and decontamination company. Personnel number approximately 40 officers and 450 non-commissioned members. Equipment includes approximately 260 wheeled vehicles. The battalion is located in the DAA. Its headquarters is centrally positioned in respect to its deployed subunits. The Repair Parts Company is responsible for the accounting, procurement, receipt, warehousing, and issue of most first and second line repair parts required by the division. It holds a 30-day stock of these parts. The Stores Company is responsible for handling a limited range of fast-moving general, technical, and ancillary stores, consolidating receiving and bulk breaking requirements, receiving and backloading repairable stores, salvaging material returned from units and handling stores and amenities in transit to units. The Laundry, Bath, and Decontamination Company encompasses 4 functional platoons, 3 of which are deployed in support of brigades and the 4th in support of division troops. In addition to laundry, bath, and clothing exchange services, the company provides limited decontamination for the division's personnel and has a very limited capability to decontaminate vehicles and equipments. The Maintenance Battalion provides Level 2 repair and recovery services for division troops and heavy repair and recovery elements to complement and augment the forward repair and recovery tasks of the disc group service battalions. It also carries a stock of repair parts to support its ongoing activities. The Maintenance Battalion is organized into a headquarters, an administration company, forward repair company, recovery company, tracked vehicle repair company, wheeled vehicle repair company, weapons and electronics company, and repair parts company. It deploys within the DAA. Its administrative company provides first-line administrative support to the battalion. The battalion structure includes approximately 60 officers and 1,800 non-commissioned members, plus 730 vehicles. The Forward Repair Company performs forward repairs for division troops and units, augmenting the forward repair capability of disc group service battalions. It is functionally organized into MRTs, specializing in heavy track vehicles, such as tanks and self-propelled guns, and heavy engineer equipment, medium track vehicles including armored personnel carriers and engineer vehicles, wheeled vehicles and ancillary equipment such as weapons, fire control, communications and radar systems, and heavy material and welding services. The Recovery Company provides recovery services to the division including backloading, cross-loading, recovery for traffic control purposes, and forward recovery augmentation as required. It uses armored recovery vehicles and heavy equipment transporters to recover heavy tracked vehicles and engineer equipment, and light recovery vehicles to recover APCs and wheeled vehicles. It also includes some heavy and medium MRTs, which support these recovery activities. The Tracked Vehicle Repair Company performs repairs to tracked vehicles and engineer equipment which cannot be performed by MRTs. It includes 2 platoon-sized workshops, each with the appropriate special equipment vehicles, tradesmen, and tools required to repair tanks, self-propelled guns, and APCs. It also incorporates an ancillary platoon, which provides the supporting material, machinery, welding, and refinishing services. The Wheeled Vehicle Repair Company performs repairs to wheeled vehicles which cannot be completed forward by MRTs. It includes 3 platoon workshops with SEVs, tradesmen, and the specialized tools required to repair larger vehicles, engineer equipment, and the full range of medium and light vehicles within the division. An ancillary platoon provides supporting material, machinery, welding and refinishing services, and a tire repair capability. The Weapons and Electronics Company consists of SEV-equipped platoon workshops, which repair small arms, heavy weapons, mortars, fire control systems, instruments, imagery and observation devices, remotely piloted vehicles, generators, batteries, communication equipment, computers, and other specialized electronics, guided missiles, and radar. Lastly, a repair part company provides repair parts for Level 2 repairs within the division. The disc group is organized to provide timely and flexible support to the division in operations. Its structure provides for speedy deployments and allows its elements to be located as close to combat groupings of the division as the situation permits. The proximity of these elements to the forward area dictates a high standard of training in defensive skills. To cope with its role and responsibilities, the disc group relies on the dedication, stamina, and determination of every combat service support soldier.
All members of a country's armed forces are entitled to prisoner of war status should they be captured. PWs are permitted to keep their personal equipment such as NBC gear, steel helmets and flak jackets, uniforms including rank badges and identity tokens, and minor items of a personal nature. As soon as practicable, a tag is initiated by the capturing unit, which includes a listing of all documents and equipment found on the PW. After being disarmed and searched, the PWs and their confiscated equipment are sent back to the unit PW collecting point in the A2 echelon area. Units are responsible for feeding, transport, and general care of PWs while they're in their custody. Where possible, PW officers, non-commissioned officers, and other ranks should be segregated from time of capture, and their silence must be enforced. This ensures that prisoners do not warn or influence others to attempt to escape, commit suicide, or not to respond to questioning. Female PWs are segregated from male prisoners and are to be treated with the respect due their gender. They will not be stripped or searched by or in the presence of males. Units will not conduct unauthorized interrogations, nor will they provide food, drink, or tobacco without authority from intelligence personnel. PWs will be evacuated from the forward battle area as speedily as possible so as to permit relevant and timely interrogation and to meet the requirements of the Geneva Conventions. A PW collecting point is established by the Brigade MP platoon, just to the rear of the forward battalions. It's located near the main supply route to permit easy access by rearward moving vehicles. The collecting point involves a segregation area, some rudimentary shelter, and possibly an interrogation area. The capturing units deliver prisoners along with any personal property, maps, papers, photos, letters, documents, etc., taken from the PWs. All seized property is listed and placed in a container bearing the prisoner's name and PW tag number. Large sums of money or other valuables will be passed on to the field cashier, and a receipt for the items will be given to the PW. The military police are responsible for the custody and administration of PWs from the time they're handed over at a brigade collecting point, during evacuation to the division PW cage, and on to the Corps holding area, and to base PW camps. Escorts and guards are normally provided from within MP resources, although units may be called upon to assist as required. PWs are to be provided with protective equipment and instructed in procedures to be followed in the event of a chemical or nuclear weapons strike. Wounded PWs will be given normal medical treatment and are evacuated through medical channels in the same manner as our own wounded. Guards and escorts for wounded PWs are provided from non-medical sources. The treatment and disposal of PWs is the concern of all branches of the staff. Close coordination is essential to ensure that the provisions of the Geneva Conventions are correctly observed and that the control and planned evacuation of PWs is properly undertaken. The G1 staff issues instructions pertaining to the general administration and care of PWs, the methods to be employed for their custody and evacuation, and a definition of the type of work on which PWs may be employed. The G2 staff directs the priority for interrogations and the exploitation of captured documents and equipment. The G3 staff provides PW forecasts and issues instructions for the collection and classification of PWs. The G4 staff issues directives concerning rations, accommodation, clothing, and transportation.
Being done quickly from
In addition, the Division Provost Marshal, in consultation with the G4 and G1 staffs, is responsible to coordinate the evacuation of PWs, and through the G3, to advise units of the location and time the PW collecting points and cages will commence operations. The G1 and G3 staffs, in consultation with the G2 and Division Provost Marshal, determine the requirement for a PW cage in the division rear area. The need is based on factors such as the distance from the brigade PW collecting points to the Corps holding area, the availability of transports and escorts, whether extensive division-level interrogation is to be conducted. The detailed siting and operation of the cage is the responsibility of the commanding officer of the division MP company. The cage is constructed by the division engineers. It includes segregation areas for groups of officers, non-commissioned officers, other ranks, deserters, and females. At a minimum, a command element and one MP section, augmented by other personnel, are required to operate the division PW cage. The transport of the PWs from the brigade collecting point to the division cage is arranged by the Service Battalion Logistics Operations Center. On arrival at the division cage, PWs are again searched and segregated by groups. Teams from the Division Intelligence Company may conduct interrogations to extract information of immediate tactical value and to identify those PWs worthy of more intensive examination. These interrogations may be conducted at either the division cage or brigade collecting points. PWs are only required to give their name, rank, service number, and date of birth, and physical or mental violence or humiliating treatment cannot be used to obtain more information. PWs are held at the division cage until such time as transport is available to evacuate them rearward. The Corps PW holding area is located well to the rear with easy access to the MSR. The evacuation, custody, and administration of PWs at the installation is the responsibility of a platoon assigned from the Corps MP Battalion. The platoon is specifically involved with the establishment and manning of the installation, completing the necessary staff action and administrative arrangements, carrying out custodial and limited escort duties, and conducting inspections required under the Geneva Conventions. An interrogation center is established by the Corps Intelligence Battalion near the facility. The officer commanding the center is responsible to strictly enforce regulations pertaining to the conduct of interrogations and the treatment of PWs. He supports and controls the activities of the interrogation teams and initiates the necessary liaison with the Corps G2 staff, the Intelligence Collection and Analysis Center, and his battalion headquarters. The interrogation center is organized into a command post for the direction and monitoring of the interrogation process, including the flow of PWs and dissemination of the intelligence. A support cell, which conducts research, collation, and analysis of information or intelligence required for the interrogations. A preparation area, where the PWs are readied for questioning. And an area where teams conduct all interrogations. intelligence interrogation teams monitor the PWs prior to interrogation and develop a method of approach which is coordinated with the intelligence support cell. They conduct the questioning, prepare reports, and review them with a representative of the support cell and the OC of the center. These teams process the prisoners as quickly as possible and advise the MPs of any individuals who merit special attention. Prisoners are categorized according to their intelligence value. Category A PWs include those whose knowledge of the enemy war effort makes it necessary for them to be interrogated without delay. They include general officers and heads of staff sections, scientific, technical, and psychological personnel, personnel with a knowledge of communications or cryptographic equipment, political officers, others who may have access to operational or logistics matters, personnel serving in intelligence-related appointments, and flight crews with knowledge of plans and capabilities. Category B PWs are those who have enough information on any subject of intelligence interest to warrant a second interrogation. Category C includes PWs who have only information of immediate tactical value. Category D PWs are those having no intelligence potential. The main principles to be observed in evacuating PWs are to always treat and handle them correctly and to minimize their exposure to unnecessary hazards, and to move them rearwards as rapidly as interrogation and transport availability will allow. Trucks are the normal means of transport used for evacuation, and they can hold 30 to 40 standing prisoners. When PWs are evacuated by air, a minimum of 2 escorts per aircraft are provided to protect the crew and to provide for the security of the prisoners during the flight. If rail transport is available rearward from the Corps administrative area, it might be used for PW evacuation. The MP escort party would normally be augmented by guards drawn from any available source. If PWs are turned over to an Allied force, a Canadian liaison officer is assigned to the receiving force to ensure that prisoners are treated in accordance with the Geneva Conventions. PWs captured within Corps boundaries are the responsibility of the Government of Canada, as well as that of the individual or unit capturing or holding them. They must at all times be treated fairly, firmly, and humanely. It should not be forgotten that the enemy's treatment of our personnel who may be taken prisoner may largely depend on how we treat our captured enemy soldiers.
A threat-forward detachment has slipped across the FIBA and seized a piece of key terrain. The division commander has ordered the depth brigade to dislodge the enemy incursion prior to the arrival of first echelon elements. Reconnaissance has reported the enemy digging in, along with signs of mining and other obstacle development activity on the main approach to the position. Mindful of the requirement to maintain the momentum of the attack, the leading tank squadron has attached its 2 mine rollers. These, along with its 4 permanently mounted mine plows, configure it for an encounter with mines and other obstacles. The initial squadron deployment places its mine rollers well forward as part of the lead elements. The lead commander expects to find conventional and scatterable mines at bridge sites, around roadblocks, at intersections, on the shoulders of sharp curves and narrow tracks, in old ruts, and beside blown culverts and craters. Hasty minefields of approximately 150 mines can be laid by a threat mobile obstacle detachment in approximately 20 minutes, with a 3-row configuration covering a frontage of about 300 meters. These unmarked, hastily emplaced conventional or scatterable minefields will most likely be covered by fire, and the first indication of their presence may be the destruction of a vehicle. Immediate suppressive fire would be returned on the enemy position. Smoke would be used to cover the stricken vehicle, to assist with the evacuation of crew casualties, and to help conceal the forward movement plow and roller teams. Reconnaissance elements will attempt to find routes through these minefields. Or, if there is no alternative, will define its edge and begin to recce a possible breaching site. A hasty breach will then be attempted, which uses the on-hand assets of the battle group and is accomplished without a loss of momentum directly from the line of march. Should it extend beyond a 30-minute time frame, increasingly severe opposition will be met, including the possibility of the minefield being thickened by artillery-delivered scatterable mines. The battle group would be divided into a support force, a breaching force, and an assault force. A support force to suppress the defenders with direct and indirect fire and to obscure the breaching activity. A breaching force to conduct the breach, mark the lanes, and secure the far side. And an assault force to continue the attack against the objective. The breaching force will have its organic tank-mounted mine plows and rollers for clearing and proofing of lanes, as well as mine detectors and probes. In addition, lane clearing charges may also have been allotted to the force from Division Engineer Resources. Breaching operations would involve the support force engaging targets and laying down smoke, while the breaching force maneuvers into position. At least 2 lanes would be attempted through the minefield, each handled by a breaching team. The teams would lead with the plow and proof the lanes with the roller. The lanes are marked by the rear elements of the breaching force once the success of the breach is assured. Once across, the breach force regroups and provides fire support for the oncoming assault force. Mine clearing equipment is most effective when used with roller plow teams. The roller will lead when there is a known or suspected minefield threat. Upon detection of a minefield, the roller tank will fire its smoke dischargers and move to cover. The plow then proceeds to clear a lane by passing the roller, continuing to at least 100 meters plus of where the last mine was detonated. And the roller then moves forward to proof the lane. As a last resort, expedient methods of breaching may also be employed, such as aiming unmanned vehicles at the objective, or using tank dozers to clear surface landmines. Bulling through, where additional casualties must be accepted. Hand breaching, although slow and dangerous, may be the only alternative. Hasty breaching operations are conducted as a normal activity of the combat team. Mine rollers and plows offer tanks the capability of maintaining the momentum of the advance, and engineer reconnaissance and support elements are deployed well forward, where they can report and act with a minimum of delay. Wherever possible, these minefields must be breached in a matter of minutes so as to minimize casualties and prevent an enemy from reinforcing the objective area.
In anticipation of a requirement to breach an enemy minefield, the battle group has been assigned explosive lane-clearing munitions to back up its roller and plow-equipped tanks. This munition has been provided through normal replenishment activities and is easily handled by resupply vehicles. It has undergone its basic preparations for firing in the division administrative area. Contact has been made with the enemy, and the leading elements have encountered a minefield. The battle group commander will breach 2 lanes across the minefield using his assigned explosive lane-clearing charges and briefs the supporting engineer troop commander on the requirement. The troop commander, in turn, issues a warning order for the operation, which details the engineer elements that will fire the munition and a forward RV location for the handover and final preparation of the charges.
Clear weapons and webbing over here.
RV activities include the hookup of the trailer to the towing unit, checks for continuity, and the final arming of the firing mechanism. The process takes approximately 1 hour, and any vehicle with a 24-volt electrical system and the capability to adapt the quick-release tow hitch can be used to fire the munition. The 2 firing teams, with their prepared equipment, remain at the RV awaiting final orders. In the meantime, the engineer recce sergeant goes forward to locate sites from where the lane-clearing charges are to be fired. Approaches and the firing sites should be chosen to give the towing vehicle and munitions trailer a degree of concealment and allow them to be properly lined up with the desired direction of the lane. The firing site should be on relatively level ground with no low obstructions which will interfere with the launch and be about 150 meters from the near edge of the minefield. The recce party also determines the firing data calculations, which are mainly based on wind speed and direction, and the temperature of the rocket motor propellant. The firing data determines the angle of elevation for the launcher and the approximate line of projection of the charge to produce a lane in the desired direction. Back at the RV, final orders are received. The firing data is applied to the launchers, and vehicles and their trailers depart the RV. Under covering fire of the support force, the firing units move forward, pick up a guide, and are taken to their predetermined firing positions. The remainder of the breaching force and the assault force waits in readiness. Once in location, the final interconnects and continuity checks are completed, and the system is operational.
Rocket continuity good. Trailer release continuity good. Elevation release continuity good. Fire now!
The Viper is normally fired as soon as it is in position to ensure a maximum of surprise
and to reduce the chance of its engagement by enemy weapons. The lane created by the explosion clears approximately 90% of all mines with fuses that are susceptible to blast. When possible, the lane will be proofed by roller-equipped tanks prior to passage of the assault force through the minefield. Most of the undetonated mines are contained within the lane skip zone, which runs parallel to the trench produced by the charge. The safest passage for vehicles may be found by placing one track in the hose trench. The lanes and their approaches should be marked in the conventional manner, although the trench produced by the charge will initially provide sufficient guidance for the balance of the breaching force to complete its task. Although lane clearing charges can be quickly fired, some time is required for preparation of the munition, from its handover at the DP to its departure from the RV. This time factor, along with the strength and direction of the wind, must be considered when planning the employment of lane-clearing munitions. This production has depicted a simplified scenario, which can be conducted in conjunction with deliberate minefield breaching operations.
Airborne thermal imaging sensors have indicated the presence of vehicle tracks and recently disturbed earth across the brigade's axis of advance. Later, reconnaissance has confirmed the presence of a minefield, determined that it could not be bypassed, and located a potential breaching site. A patrol and a minefield reconnaissance party consisting of a commander and 2 men has been dispatched. They will locate routes to the minefield, enemy positions covering it, and provide details on any other obstacles involved in the barrier. On arrival at the suspected edge of the minefield, the commander fixes his position on the ground and establishes the bearing he will take through the minefield. Equipped with plotters, pins, fish line, markers, cutters, and a detector, they will be able to determine the forward edge, any lanes through, and details on the makeup of the minefield. The recce proceeds with the number 1, securing the marking line and moving forward, searching a path of little more than ½ meter in width, neutralizing anti-personnel and marking any anti-tank mines that are located. The commander follows behind, keeping direction and securing the line. He examines all reported mines and records their position by tying loops in the fish line. The number 2 follows 5 meters behind, using a detector to find any deeply buried metallic mines or others which the number 1 may have missed. When no more mines are encountered, it is assumed the forward edge of the minefield has been reached, and the party retraces its steps, picking up the markers and reeling in the fish line. On return to the starting point, all stores are checked to ensure nothing has been left behind which might reveal to the enemy that a reconnaissance has taken place.
Hey, Sarge, we got one.
Good. What kind?
AP.
On completing the recce, the fish line is laid out, which provides information on the limits, makeup, and density of the minefield. If sufficient strips of the minefield have been recce'd, its general parameters can be determined. It has been decided to immediately conduct a hasty, silent breaching operation and develop 2 lanes across the minefield, each approximately 8 meters wide and 120 meters in depth. Breaching groups comprising an engineer field troop have been assigned to one of the lanes, and an infantry team comprising assault pioneers and other infantry personnel has been tasked to the other lane.
Task. Provide engineer charge.
The planning time for the hand clearance of a vehicle lane is 4 hours by day and from 5 to 6 hours at night, working under favorable conditions.
Guide, giant viper.
The breaching of a 1 meter foot lane at night by a section-sized team would take approximately 1 hour.
No change.
The breaching groups are organized into a setting out party, 4 breaching parties, a pulling party, reserve personnel, and a stores detachment. The lane commander is responsible for the coordination of the breaching operation. He lays out the pattern of the breaching activity, starts the various parties working, maintains safety distances, allots work-related tasks, details duties in later phases of the activity, and reports on progress. The setting out party lays out the basic lane clearance pattern for the minefield. They lay a base tape which provides the start point for the first breaching party, the right-hand guide tape denoting the edge of the lane, cross tapes to provide the start lines for additional breaching parties, and a finishing tape to mark the far edge of the minefield. Throughout, they neutralize and lift any anti-personnel mines encountered within a 1 meter wide lane centered on the tapes, and mark any anti-tank mines that are encountered. Each of the breaching parties are spaced at least 50 meters apart and work down a 2 meter wide strip. They detect, neutralize, and lift anti-personnel mines and place them to the outside right-hand tape. They also detect, uncover, and mark anti-tank mines, which are left for the pulling party. On completion of the clearance task on the 2 meter strip, the party returns and starts another parallel strip until the 8 meter wide lane is completed. The pulling party works behind the breaching parties, neutralizing and lifting mines and moving them clear of the lane. They then check to ensure there are no mines buried beneath the holes. In instances where noise or damage created by the detonating of a mine is not a problem, the pulling party can use cables to extract the mine from the ground. Throughout the duration of the operation, concurrent action takes place with the setting out party completing its task, the breaching and pulling parties continuing with detection and removal of mines, and the stores detachment providing any required equipment or material. The minefield lane would be marked by the setting out party so that it can easily be seen by the oncoming assault group. Later, it would be permanently marked by follow-up elements. Should the breaching activity be discovered or significantly delayed, it may be necessary to employ Bangalore torpedoes or other explosive devices to quickly complete the opening of a vehicle lane or footpath through the minefield. Hasty, silent minefield breaching activities would normally be conducted at night or under conditions of limited visibility. They take time to complete and are continually subject to discovery by the enemy through his ongoing surveillance or through accidental detonation of a mine.
Division engineer tasks can be broken into 4 basic functions, which involve mobility, counter-mobility, survivability, and general engineer support activities. Mobility involves clearing and opening the way so that combat units can maneuver on the battlefield. Mobility tasks include filling craters, removing blowdown, clearing abattis, traversing ditches, breaching and bypassing minefields, providing bridges, ferries, and boats, maintaining roads, fords, and crossing sites, lifting booby traps, supporting EOD operations, and clearing debris, barricades, and rubble. Counter-mobility involves the reinforcement of terrain or the creation of artificial obstacles to delay, disrupt, or kill the enemy. It encompasses planning, construction, and the logistic and transportation efforts associated with its accomplishment. Counter-mobility tasks mainly include point targets, such as road craters, abattis, rubbling, mining, and demolitions of bridges, utilities, or facilities, and linear targets, such as anti-tank ditches, minefields, and routing. Survivability involves the development of protective positions through extensive digging assistance for critical weapons, command and support systems in the main defense and covering force areas, as well as reinforcement of strong points and OPs. Assistance in the construction of wire obstacles. Reinforcement of defensive positions. Improving observation and fields of fire, and developing natural obstacles. The last function entails general engineer support, which comprises general engineering activities performed rearward of the forward brigades. General support tasks include construction, repair, and maintenance of main supply routes, construction of protective works for ammunition and POL storage sites, providing water points, support to decontamination operations, and the provision of engineer intelligence. Engineers must receive advance warning of pending operations so as to get on with issuing preliminary orders, reconnaissance activities, and the ordering of stores and materials. They must also be included in reconnaissance groups at all command levels. The execution of engineer tasks requires the careful and timely deployment of engineer resources. The most efficient results are achieved by centralized control at the highest practical engineer level. This allows engineer units to be employed where the work is, rather than being restricted to working within a particular formation boundary. Once work begins on an engineer task, it should be completed by the same unit. Discontinuity causes delays, lost time, and wasted effort. There are seldom enough combat engineers to conduct all tasks required of them in a given period of time. The priorities for engineer work must be decided between engineer and formation commanders at the highest possible level. Engineers can be redeployed from lower priority tasks if the situation warrants. An engineer commander carries out the functions of commanding his unit, advising the tactical commander, and acting as the link between the formation and the next higher engineer commander. His location is dependent upon the relative importance of the tasks underway and upon those being planned. In situations when he cannot be with the supported commander, an engineer liaison officer will be co-located at that commander's headquarters. The command of division engineer units is normally centralized under the commander division engineers, with its elements assigned to a specific area or tasking. If its elements are decentralized in support of the brigades, the CDE retains technical control of their activities. The CDE controls all engineer activity within division boundaries. He is also the engineer advisor to the division commander.
CR can look after that.
The division engineer group is organized and equipped to provide the minimum continuous engineer support required by the division.
The group consists of a headquarters, 2 field engineer regiments, 2 armored engineer squadrons, and an engineer support regiment. Headquarters Division Engineers has G3 and G4 staff branches, headed up by the Chief of Staff. It is normally co-located with an engineer unit, which provides for its administrative support and protection. The Chief of Staff organizes the day-to-day functions of the engineer headquarters and details the operational activities of units of the group. He is responsible for the coordination and execution of the engineer plan. The G3 is the principal operations staff officer. He directs and supervises the G2 and G3 staff, which completes the detailed work on engineer plans and orders, and directs the production of engineer intelligence. Included in his staff are the G3 Operations, who controls the engineer command net, keeps the battle map updated, maintains records, files, reports, and returns, and mans the step-up for the headquarters. G3 Signals, who is responsible for all communications within the division engineer group. The G3 Plans is responsible for the preparation of plans, orders, and instructions, and a liaison section. Headquarters Division Engineers makes extensive use of liaison officers who carry orders and information to the engineer units. Liaison detachments are established at division main and rear headquarters and at each brigade. These LOs represent the commander at various headquarters, but do not act in an advisory capacity. The G2 staff is responsible for the collection, collation, and dissemination of intelligence, with emphasis on terrain analysis and enemy techniques in obstacle construction and booby trapping. They maintain accurate records and maps of all obstacles in the division area, and are responsible for developing an engineer intelligence collection plan for use by engineers and other arms units. They also provide a liaison staff to the Intelligence Collection and Analysis Center. The G4 staff is responsible for the provision of ammunition, explosives, defense stores, and engineer resources to the division engineer units, for the preparation of administrative orders and instructions, and for coordinating and controlling the dumping of resources in support of engineer activities. They also effect liaison with division transport agencies and coordinate personnel, vehicle, and equipment replacements. The field engineer regiments provide combat engineer support to the brigades and to division troops. They are manpower-oriented and depend on the engineer support regiment for heavy equipment assistance. Each regiment is made up of a headquarters, 3 field squadrons, and an administration squadron. The field squadrons have a small headquarters and 3 field troops. Each troop has 4 field sections and a multi-purpose engineer vehicle section. A troop is normally affiliated with a battle group, and the troop commander acts as the engineer advisor to the battle group commander. The troop warrant officer runs the troop command post, monitors the activities of the field sections, and looks after the troop administration. As the troop's most experienced field engineer, he is also responsible for the on-site control of troop-sized tasks. The troop commander is also assisted by the troop recce sergeant, who conducts engineer reconnaissance for the troop. The troop's equipment includes 2 cargo vehicles. One carries ammunition and demolition materials, while the other transports stores, which are used by the field sections. Each field section operates from an APC, equipped with a dozer blade and an earth auger. In addition, the vehicle carries hand tools, demolition accessories, mine detectors, as well as a chainsaw, a jackhammer, and similar type tools. The multi-purpose engineer vehicle section is equipped with 2 MPEVs, which provide the troop with an additional digging, earth-moving, and bulk lift capability. The administrative squadron provides the required maintenance, supply, transport, medical, and messing support to the regiment. Maintenance troop provides first-line repair and recovery capability for the regiment, and spare parts for both tracked and wheeled vehicles. The supply section carries the regimental maintenance load of supply items, such as clothing, personal equipment, and weapons. The medical section comprises the unit medical station and 3 tracked ambulances. The transport section administers unit transport resources and carries the regiment's reserve portion of the basic fuel load, and the messing section provides hot meals as often as the tactical situation will allow. The engineer heavy equipment resources of the division are provided from the Engineer Support Regiment. They remain under the centralized control of CDE and are allocated to the field engineer regiments for specific operations or for periods of time. The support regiment includes a resources squadron, an equipment squadron, and an administrative squadron. The resources squadron provides the engineer stores and services required by the field engineer regiments. Its subunits include a water supply troop, a construction troop, a bridging troop, a mine countermine troop, and an engineer stores troop. The water supply troop consists of 14 detachments, each capable of producing 1,500 gallons per hour. Normally, 3 water supply detachments are placed in support of each brigade, and the remainder are allocated to support the division troops. The construction troop provides the construction engineering services required by the division. It can provide carpentry, plumbing, and electrical services. It also can supply supervisory personnel to larger projects. The bridging troop holds 2 sets of 31-meter medium girder bridge, tactically loaded on trucks and trailers. This bridge is constructed by subunits of the field engineer regiments and is primarily used to replace bridges laid by the armored bridge layers. The troop also carries 60 assault boats and 10 cargo boats. Finally, the troop holds 4 sections of Class 60 trackway to assist entry and exit at water crossing sites. The mine countermine troop carries the equipment necessary to support both minefield laying and breaching operations. The mine laying section has 6 mechanical mine layers, each having its own racks and arming tables. They carry a basic load of 3,000 mines. In addition, the section holds 6 scatterable mine dispensing systems and minefield marking stores. The countermine section holds all mechanical and explosive minefield breaching systems, primarily for use by the armored engineer squadrons in support of breaching operations. This includes 16 trailer-mounted Giant Viper charges, 4 sets of mine rollers, and 12 sets of mine plows. The Engineer Stores Troop carries engineer and defense stores, as well as rapid demolition devices, cratering kits, and explosives used by the field engineer regiments. Its equipments include air compressors and pneumatic tools. The troop also includes a diving section, which holds equipment for 16 combat divers. These items are drawn by the field engineer regiments for use by their diver-trained sappers on a task-required basis. The equipment squadron provides vehicles and heavy engineer equipment to the division engineer group. It includes a dozer troop, a dump troop, and 2 excavator troops. The dozer troop consists of 4 sections, each with an APC dozer, 4 high-speed armored dozers, a low-speed armored dozer, and a 20-ton tractor-trailer. The dozers may be deployed independently to support combat units, but normally work with sappers of the field engineer regiments. The dump troop equipment includes 24 dump trucks and 12 front-end loaders. These are employed primarily in road construction and maintenance tasks. They may also be employed in support of mine dumping programs. The 2 excavator troops function in support of the field engineer regiments. Their equipments include 4 trenchers, 4 light and 12 heavy excavators, which are mainly used for digging in command posts, crew-served weapons pits, battle trenches, and aid stations. Each troop also has 4 graders, used primarily for route maintenance, LZ construction, and for improvements of exits and approaches at ferry and bridge sites. 6 low-speed armored dozers hauled by tractor-trailer combination, and a 30-ton hydraulic crane. The Administrative Squadron provides the administrative services for the regiment. Its organization and equipment are similar to the administrative squadrons of the Field Engineer Regiments, except that it has additional MRTs and refueling vehicles to support its varied worksite locations. The 2 armored engineer squadrons are identically organized, each having 5 armored engineer troops, equipped with 2 armored bridge layers and 2 armored engineer vehicles, an engineer support troop, and a service support troop. The AVLBs provide the division with assault bridging capability. The bridge can span a 20-meter gap and can carry a 50-ton load. The AVLB has the same armor protection as the main battle tank, allowing it to move with armored formations. It also carries spare bridges and fascines. The AEV allows sappers to conduct engineer tasks under fire in support of operations. It's equipped with attachments allowing it to excavate or move earth, breach anti-tank ditches and remove abattis, scarify road surfaces, clear rubble and fields of fire, and prepare riverbanks for water crossings. The AEV can be used as a demolition firing point and to launch lane clearing charges during minefield breaching operations. The Engineer Support Troop provides vehicles and stores lit to sustain the armored engineer troops. The Service Support Troop looks after the normal combat service support needs of the squadron and provides the required MRTs to service the squadron's AEVs and AVLBs. Sappers are capable of conducting many tasks and are a valuable resource. They remain soldiers first and engineers second, and are prepared to fight as infantry if required. Their reliance on a continuing supply of equipment and stores, and their vulnerability when conducting engineer tasks, are factors which must be considered in any operational plan. Units of the division are moving to their assembly areas prior to occupying defensive positions along the Black River. Earlier, the Commander Division Engineers received a briefing from the Commander Corps Engineer, which outlined the Corps barrier plan and detailed the allocation of Corps Engineer resources to the division. In concert with the Corps' requirement and the Division Commander's defensive layout, the CDE prepares his plan, which is aimed at implementing his sector's portion of the Corps barrier, indicating likely locations for obstacle development throughout the division area. The CDE's G3 staff coordinates the plan with the division operations staff, prepares the required overlays, allocates reconnaissance tasks, and requests any additional resources required from Corps. The G2 staff puts together the Engineer Intelligence Collection Plan, which results in taskings that will be distributed downwards to other arms and engineer units. These tasks will provide information on river currents, bank heights, fording sites, and the like. Orders are then delivered to the Field Regiment's headquarters in the form of obstacle task tables and engineer intelligence collection tasks. Engineer reconnaissance in support of these tasks is conducted as early as possible, often when other units are still in their assembly areas. The resulting recce information is consolidated at regimental headquarters and passed back to CDE HQ. There, the staff review the reports and finalize their portion of the Corps barrier plan. The completed plan is then delivered to Corps. Once the division engineer plan has been approved, tasks are issued and resources, time, and priorities are established in the form of engineer annexes, traces, and overlays to the division operations order. An obstacle task table and a work schedule are built up for the execution of tasks within the division area. Some tasks are approved as received, so that work can begin without delay. The division engineer G4 staff, based on the G3's directions, allocated out the resources provided by the Corps Engineer Brigade. These resources are employed to assist with the various barrier tasks or to undertake specific Corps-directed tasks, such as survey, route maintenance, or the provision of amphibious bridging. The staff also negotiate the positioning of mine and explosive dumps and defense stores within the division area, and they coordinate the transport required for the delivery of these items, some of which will be taken directly to the task sites. As well, the staff allocates the heavy equipment resources of the Engineer Support Regiment, which move directly to the task sites and start work. The division engineer group will initially be employed on Corps and division barrier tasks. As higher priority obstacles are completed, selected field squadrons may be detached to support their affiliated brigades. The remaining field squadrons continue under command of the CDE and complete their work on Corps and division barriers, both in-depth and on flanks. They would also undertake any protective or general engineering tasks required in support of division troops and division service group units. The Armored Engineers squadrons are normally grouped to support the covering force operation. After withdrawing across the FIBA, they are reassigned in support of the counterattack force. Throughout the covering force area, engineer tasks concentrate on slowing down the enemy and causing him to commit his engineer resources. These tasks mainly involve routing, mining, demolition and cratering on routes, construction of anti-tank ditches, wire obstacles, booby traps, and abattis. The covering force requires axial and lateral routes to give it the required mobility to both delay the enemy and avoid decisive engagement. Here, engineers assist with maintenance on reserved routes, using assault bridging to cross critical obstacles, clearing debris in urban areas, advice on trafficability, alternate crossings should reserve demolitions be fired before all troops can be withdrawn, and some digging assistance for weapons positions. Engineer activities in the main defense area are generally directed at creating a continuous barrier across the division front, and then strengthening the barrier with obstacles in depth. Typical tasks involve constructing anti-tank ditches, demolishing bridges, fords, and swim sites, mining, cratering, and routing of routes, and creating abattis. Also included are the maintenance and improvement of routes for blocking and counterattack forces, which may involve the use of assault bridging, trackway, and engineer equipment well forward. The weight of artillery fire and airstrikes available to the enemy requires that considerable effort be put into the digging in of battle positions for tanks, guns, and anti-tank weapons, and headquarters and communications sites. Work priorities within the main defense area may be categorized into Priority 1 tasks, which include the demolition of major bridges and the mining of fording sites. Priority 2 tasks involve development of major minefields, both on the FIBA and in depth. Priority 3 tasks, concentrating on road demolitions, nuisance mining and abattis within the brigade areas. And Priority 4 tasks, which provide for digging assistance. As the core barrier is developed, lanes are left through which the covering force can withdraw, and gaps for counterattack operations are provided. When these are no longer necessary, they are sealed using demolitions, hand-laid or scatterable mines. As the enemy advance closes up on the forward edge of the battle area, engineer units are withdrawn into assembly areas where they rest and replenish before starting to work on depth obstacles. When employed in a counterattack role, the AEVs of the Armored Engineer Squadron augment the Armored Regiment's tanks, which are equipped with rollers and plows for the hasty breaching of minefields. They could also employ explosives to assist with lane clearance, and the AEVs may be used to fill in ditches, lay trackway and fascines. In addition, its AVLBs assist in the crossing of small rivers. Engineer elements working on specific tasks in the main defense area would normally be placed in support of a brigade. Engineers detached to the covering force would be placed under command of that force. In times of emergency, engineers can be employed as infantry. In this situation, a field squadron would be grouped under the command of a battalion, occupying a company-sized battle position. They must then be allocated both anti-armor and mortar resources to assist their survivability. Engineers are a limited resource, and their employment as infantry should only occur in very critical situations. The engineers are an essential part of the defensive battle. Their ability to rapidly emplace effective obstacles and their assistance in digging is a key component in the division's fight against the enemy. When threat forces decide to hold an area, defense is based on an anti-armor framework designed to repel attack from all directions. The enemy has the type and quantity of engineer resources to carry out mine-laying tasks and rapid digging, and thus can make the transition from offense to defense in a short period of time. The defense is organized in depth, incorporating a security zone and a main defense belt. The advancing force will encounter many obstacles in the security zone and as it penetrates the main defense belt. Engineers providing close support to the force will be required to perform all types of tasks. Engineers must be grouped to overcome minor natural and artificial obstacles, and the resources must be protected while moving and working if they are to give effective support. Mobility tasks in support of the force involve reconnaissance, mine clearing, minefield breaching, gap crossing, clearing debris, barricades and routes, and in maintenance and construction activities. Route reconnaissance is conducted in conjunction with the advancing division covering force and the brigade screens. It involves determination of going, classification and location of routes through or around obstacles, and assessments of time and resources required to make routes passable to the advancing main body. Minor artificial obstacles will have to be dealt with, and engineers will become involved in clearing booby traps, which may be incorporated in obstacles and randomly laid in built-up areas. Opening lanes through wire barriers, obstructing mounted and dismounted approaches. Clearing nuisance mines from minor obstacles, ford sites, and in likely assembly areas. And clearing abattis from roads and tracks. Minefield breaching will be required to maintain the momentum of the offense. Breaching will normally be limited to hasty techniques by armored engineers or armored units. Throughout the offensive battle, the Corps will encounter a number of short gaps which will impede its movement. Gap crossing resources are grouped by type at various levels to provide sufficient support to the formation without causing unnecessary logistical problems. The resources include support bridging, consisting of fixed and floating bridges, amphibious bridging resources, and assault bridging, such as armored vehicle-launched bridges. Within the division, gap crossing centers mainly on the AVLBs of the Armored Engineer Squadrons. Its bridges must be quickly recovered or replaced once the advancing elements have crossed. Small gaps can be traversed by fascines emplaced by a variety of equipments. Class 60 support bridging is used in a variety of tasks throughout the Corps area. It is centrally held and controlled at Corps level, with only limited quantities held within a division. The only support bridging found within the division is the medium girder bridge. Each division engineer support regiment holds sets of MGB to allow for the recovery and reuse of the AVLB's bridges in the assault role. Additional sets of MGB are held by the Corps Engineer Support Group and are intended for use during the later stages of a deliberate crossing or for spanning larger gaps. The Corps Amphibious Engineer Regiment holds the remaining support bridging resources. It is comprised of 2 amphibious squadrons and a floating bridge squadron. The amphibious squadrons hold self-propelled bridge elements, while the floating bridge squadron is equipped with workboats and floating pontoons that can be linked together. The regiment is capable of constructing and operating rafts and ferries. Engineers supporting a force which must move through a built-up area may become involved in the clearance of debris and barricades. This is a time and resource-consuming activity. Tasks involving the maintenance and construction of routes mainly include filling of craters, laying trackway and matting, constructing bypasses, bridges and culverts, graveling and grading of routes, and removing or clearing snow. The primary counter-mobility task in support of an advancing force is flank protection. Here, engineers assist by denying routes to the enemy, preparing hasty obstacles on likely enemy approaches, and by planning and coordinating use of rapid response scatterable mine systems in cooperation with the Division G3 and artillery staff. Survivability tasks in the offense involve assisting forces digging in against an expected counterattack. General engineering support in the offense involves the leapfrogging of water points to keep pace with the advancing force, the maintenance and construction of helipads, and the production of engineer intelligence. To maintain the momentum of offensive operations, the CDE's estimate will concentrate on identifying what obstacles are likely to be encountered and the planned grouping of resources to overcome them. Major crossings such as those involving rivers and lakes must be dealt with by higher-level engineer resources, since the division has no integral amphibious capability. Major forested areas will require additional mobility support for the offensive force. Major minefields will also require increased engineer support. These resources must be ordered early and deployed to best suit the needs for security and availability. In addition, the estimate considers routes and going, the number, load classification and condition of forward and lateral routes, as well as off-route going. This helps determine the degree of engineer support needed and the ease with which engineer equipment can be moved and harbored. Additionally, weather, hours of darkness, and location of populated areas must be brought into the estimate. Offensive planning involves the general intentions of the enemy, the time available for him to prepare obstacles and defensive works, his engineer manpower, and resources available to construct and carry out denial operations, the deployment security of our engineers on the move, and their protection while at the task site. In most cases, engineer reconnaissance elements and other resources must be deployed well forward to identify engineer tasks and to bring engineer resources into action in the shortest period of time. During offensive operations, tasks vary from multitudes of close support activities which dictate decentralized control to those which require centralized control of division and assigned Corps engineer resources, such as major obstacle crossing. Control involves a balance between the need to deploy engineer resources as close as possible to the task and yet provide for their security. Engineer elements may be grouped under command of the advance force, such as in a covering force mission, when engineer support would be in the form of reconnaissance and assault crossing elements. Engineers with the advance guard Normally a field squadron and elements of an armored engineer squadron are assigned in support and under command for movement. They are tasked to report enemy activity, to report on and find routes around or through obstacles, and provide support during assaults on enemy positions. The main body would normally contain the majority of the division engineer resources, with a field squadron grouped in support of each brigade. The remaining resources would permit the CDE the flexibility of applying the engineer effort where it is most needed as the battle develops. Engineer elements assigned to flank and rearguard forces will vary in size with the threat and would be equipped with rapid mine laying and digging capability. They would normally be grouped in support and under command for movement. Engineer resources are critical to the success of a division attack against a part of the enemy main defense area, and they should be deployed well forward with the force they are supporting. Engineer resources should be dispersed and well concealed from air and ground observation. Captured enemy equipment, engineer and defense stores would be used whenever possible to minimize the need to move our own resources forward. The field troops supporting the leading battle groups are seldom without additional engineer resources provided from the Division Engineer Support Regiment or from the Armored Engineers. These may include AVLBs and AEVs with fascine loads, possibly some rollers, plows, or explosive lane clearing charges. Engineer heavy equipment such as dozers, front-end loaders, and trucks with Class 60 trackway or matting. Some mine dispensing systems or mechanical mine layers for laying of flank minefields. And possibly some water crossing resources such as assault boats or rafting elements. The division's engineers are a key element in maintaining the momentum of offensive operations. Their work is demanding, and they require the maximum of support and protection. Wherever possible, obstacles should be circumvented so as to only commit engineer resources when absolutely necessary. The Corps Topographic Regiment and its regimental headquarters provide survey, cartographic, terrain analysis, mobile printing services, and geographical advice to the commander, Corps headquarters, Corps troop, its divisions, and Allied formations geographic staff. The regiment includes a field survey squadron, a cartographic squadron, a geographic support squadron, and an administrative squadron. The Field Survey Squadron provides precise positional data using conventional, satellite, or inertial survey methods.
Yeah, that was good.
This information is used to support navigation systems, for map and chart production, to locate various theater and corps weapons systems, including air defense guns, radars, and missiles, and for electronic warfare and directional communications equipment. The squadron deploys survey detachments to bring accurate grid survey forward from the theater area to the division rear boundary. The function is then taken over by the survey troops of the division target acquisition batteries and brought down to regimental rocket and gun areas. Survey activities are built upon an existing survey database, which includes a framework of known control points that have been established in a theater of operations. This framework is extended into the new area of operations and is used as the basis of all continuing survey activities. Control points are normally established by field survey teams using theodolites and electronic distance measuring devices.
They can also be rapidly fixed by using global positioning systems. The resulting raw survey data and control point locations are entered into the information bank of the Tactical Command and Control System. The Cartographic Squadron, from a location within the Corps rear area, provides photo or conventional line maps of the operational area. Its functions include updating, revising, overprinting and producing accurate topographical maps, mobility traces, photo maps, and special map products for specific operations. The map production process combines the control point information from the survey squadron with a series of overlapping aerial photographs. This block of controlled photography goes through a computerized triangulation process to produce a control plot. Other available data is then superimposed by the computer onto the plot. The resulting overview is compiled by computer into a contoured two-dimensional image of the terrain. A three-dimensional view of a piece of ground can be constructed. A plotter then produces the matrix, which, in turn, is used to print the map. The Geographic Support Squadron provides terrain analysis and field printing support to the Corps. Its headquarters maintains and distributes the bulk map stocks required by the Corps. Geographic support troops are detached to Corps headquarters and to each division HQ. They depend on the supported headquarters for daily maintenance and general technical support. Each troop approximates 20 all ranks and is equipped with special purpose MLVWs, trailers, and generators. Their technicians service and carry out limited second-level repairs to their specialized equipment. A geographic support troop is made up of a terrain analysis section, a field print section, and a map distribution section. A division-assigned troop is normally co-located with the division intelligence company near the division main headquarters, with its map distribution section sited at division rear headquarters. Geographic support provided by the regiment assists commanders in seeing the battlefield and using the terrain to maximum advantage. The terrain analysis section produces evaluations concerning the effects of terrain on operations by processing all available information produced by collection agencies. It provides advice to commanders and to staffs to assist in the developing of tactical and supporting plans. The section works as a part of the Division Intelligence Collection and Analysis Center, and it deploys a representative to the Division Engineer Headquarters. The field printing section presents information to the user by updating older maps and by printing tactical terrain analysis overlays. It also produces map and air photo enlargements, reductions, and overprinting, tactical traces, and overlays. The section has a very limited drafting capability to support its printing activities as well as any division headquarters requirements. It receives taskings from the Division G3 staff and the ICAC. The map distribution section receives, holds, and prepares for distribution bulk stocks of maps and other cartographic products for the division. It also provides for the needs of the field print section. The regiment's administrative squadron provides first-line combat service support to the regiment's elements located in the Corps rear area. It also provides limited second-line maintenance support for the unit's specialized equipment throughout the Corps area. The division-assigned terrain analysis team uses previously collected geographic and updated battlefield data, which has been fed into the Tactical Terrain Analysis database to answer specific questions posed by the commander or the staff. The computer analysis utilizes 6 terrain factor overlays showing slope, soil, surface drainage, vegetation, obstacles, and transportation routes to help answer queries on observation, fields of fire, obstacles, key terrain,
cover and concealment, avenues of approach, mobility corridors, and the like, within an area of operation. The slope overlay portrays the maximum slope of the surface at each point on the ground, expressed as a percentage. For example, area D equals a 15-degree slope. Data from this overlay is used to assess slope limitations of any planned locations, such as roads, cross-country routes, airfields or landing zones, and the suitability of river crossing sites. The soil overlay shows the type and condition of the surface soil. The first two letters indicate the surface material, and the third indicates its roughness. Dots and/or dashes indicate dry, moist, or wet soils. This information is useful for engineers when planning construction or repairs of roads, trails, airstrips, etc., and is vital to terrain analysts performing cross-country movement studies. The surface drainage overlay portrays water that will have an effect on the battlefield. Lakes, ponds, and reservoirs are shown as open bodies of water. Rivers, streams, canals, and ditches are defined using a 9-digit code to indicate the type of feature, gap width, bottom materials, height and slope of the banks, average water velocity, and depth. This information is valuable to engineers planning river crossing operations and the sighting of mines and other obstacles. The vegetation overlay provides detailed information on average tree diameter and spacing, including the vegetation roughness factor on the forest floor. It divides vegetation into categories of tactical significance. Coded letters and numbers indicate types and density of ground vegetation, canopy closure, and tree height. This information is used by terrain analysts in trafficability studies to calculate line-of-sight information for communications, surveillance and target acquisition planning, and to provide cover and concealment information for survivability. The obstacle overlay portrays linear terrain features that form natural and man-made obstacles, some of which are not readily identifiable on a topographic map. All obstacles shown are over 1.5 meters high and longer than 250 meters. These include, amongst others, escarpments, embankments, depressions, road and railroad cuts and fills, fences, walls, and other micro-relief features. This information is used by engineers involved in barrier and countermove planning. The transportation routes overlay portrays selected roads, bridges, tunnels, ferries, railroads, airfields, and the like over which troops and supplies may be moved during military operations. Information shown on the overlay includes roadway widths, steep grades, length and width of runway surfaces, and bridge information such as length, width, overhead clearance, and bypass potential. This information is used by engineers and the G2, G3, and G4 staffs, requiring lines of communication data. Data from these 6 basic neutral factor overlays can be combined to produce a tailored trace in response to a specific staff requirement. An aviation-oriented combined trace can, for instance, present detailed information of interest to aviation staffs and units covering a particular airmobile operation. A different combined trace can present to the G3 staff going information pertaining to the link-up phase of the same operation. In addition, ADP techniques can present data in ways which can bring target acquisition means, weapons, and communication systems to bear more effectively, and which can save time and resources during operations. For example, 3-dimensional arrays can be constructed to show actual visibility from selected observation posts and reject ones that are of limited use. Sites for weapons locating radars can be pre-selected to provide for optimum coverage. Radio path profile analysis can be constructed to assist with communications planning. And the locations of gravel and sand deposits can be provided to engineer units.
In conjunction with coordinating the topographic support received from the regiment, the division engineer staff remains the primary advisor on effective use of terrain. It assists the G2 staff in coordinating geographic support requests and in evaluating requirements, setting priorities, and selecting alternatives. The staff also tasks engineer units to collect terrain data and prepares the Topographic Operations Annex for the Division Operations Order. The Topographic Regiment provides the commander with broad area survey support, a cartographic effort that emphasizes up-to-date maps, tactical terrain information and evaluations tailored to the division's needs, a quick response printing capability, and a map distribution service. It will provide the commander with an intensive and far-reaching view of the battlefield.
The Attack Helicopter Squadron is the cutting edge of the Tactical Aviation Wing's combat power in the division. Its role in battle is to destroy enemy forces. The Attack Squadron is integrated into Division's Combined Arms Operations. The flexibility, speed of movement, and mobility differential of attack helicopters over armored vehicles allows them to quickly respond to developing enemy threats and strike the enemy at a critical point in time. Attack helicopters attain a concentration of fire by being committed en masse. They cannot seize terrain, but can dominate it for limited periods of time. The effects of weather and visibility on movement and target acquisition makes it necessary to superimpose the squadron's fire units upon the anti-armor framework of the division. To fight successfully, attack helicopter units must see the enemy and the battlefield, use their mobility to concentrate, and then destroy air defense resources, tanks, and other enemy assets. In addition, attack helicopters take advantage of all-terrain features and use suppressive fire to screen or obscure enemy capable of interfering with the mission. They strike from covered and concealed positions, using the maximum standoff range of their weapons, and employ all available supporting fire while engaging the enemy.
The squadron is organized into a headquarters, 3 attack flights, an observation flight, an administration flight, and a maintenance flight. The squadron headquarters incorporates the necessary command, control, and communications functions and provides liaison officers to assist in the planning and execution of anti-armor operations. The 3 attack flights and the observation flight are geared to provide continuous support to combat operations. Each attack flight comprises 7 attack helicopters, and each fights as an entity. Their armament includes cannons, rockets, and tow missiles. Their weapon system incorporates a forward-looking infrared target acquisition system, providing a night fighting capability. The observation flight's 12 helicopters operate in pairs. Their principal mission is to assist and coordinate the attack helicopters in the acquisition and destruction of enemy targets. The maintenance flight provides first-line servicing, including the operation of a forward arming and refueling point for the squadron, and second-line maintenance support to the attack helicopters. The administration flight provides first-line support in the areas of medical, transport, food services, and logistics. The attack squadron is a division-controlled resource with command being retained by the Tactical Aviation Wing. Operational control of the squadron, however, could be handed over to a brigade. Within division headquarters, attack helicopter operations are coordinated by the Tactical Aviation Staff in accordance with the needs of the G3 staff. The Division Air Defense Cell coordinates the safe use of friendly airspace for attack helicopter operations. Artillery coordination is handled through the Fire Support Coordination Center, and any available close air support missions will be coordinated by the Division Air Liaison Officer. Attack helicopter missions are normally pre-planned within the context of the division operation order. Occasionally, however, attack helicopters may be needed on an unforeseen basis. In this instance, a request for attack helicopter support would be made through normal command channels. A planning figure for an immediate request would approximate a 2-hour reaction time from the time of request until engagement begins. Once the attack helicopters are in the forward assembly area, the reaction time is decreased to less than 30 minutes, and from a holding area to less than 5 minutes. Generally, the squadron's attack helicopters could be tasked to support the deployment of forces, destroy enemy armor and other enemy assets, reinforce flank guards and cover gaps, assist with the disengagement of ground forces, support blocking operations, assist with rear area security, assist with securing lines of departure, augment anti-armor fire, act as a reserve, support obstacle crossing or minefield breaching operations, provide support during reorganization, and provide intimate support for airmobile operations. In addition to their principal mission, the observation flight or the affiliated brigade observation squadron are also tasked with locating covered and concealed attack routes and likely killing zones, identifying possible holding areas, battle positions and firing positions, liaison directed at integrating the helicopter battle positions with the maneuver plan of the local ground force commander, coordinating the movement of attack aircraft into their battle positions, pathfinding for the attack flights, acquiring, identifying, and handing off targets, and coordinating close air support and artillery fire. The attack helicopter is somewhat limited in the amount of ammunition and fuel it can carry, which necessitates its cycling through a forward arming and refueling point when it is involved in a continuous engagement with enemy forces. The attack helicopter mission commander therefore normally only commits a portion of his force to the actual battle, with the remainder either departing the battle area to replenish, taking on ammunition and fuel at the FARP, or returning with fuel to holding areas where they wait until called forward. When deploying in support of an operation, the squadron travels from its base location in the division rear area to a forward assembly area, to a selected holding area, then via attack routes to its battle positions. Squadron elements first move to the forward assembly area, a secure location in the rear of a brigade. Holding areas may be occupied briefly while flights wait for coordinating instructions. Attack routes are used to move from holding areas to the battle positions. Routes are selected to provide good cover and concealment, reduce the helicopter noise signature, mask them from detection by enemy radar, and use prominent terrain features to assist navigation. Battle positions are covered and concealed positions, preferably at the maximum standoff range from selected killing zones. Within a battle position, each aircraft commander chooses a firing position from which targets are engaged. Alternate battle positions are identified by the observation helicopters for continuing the attack as the battle progresses. In defensive operations, killing zones are selected through a map study and are confirmed by reconnaissance, normally in conjunction with the supported ground commander. Battle and firing positions are initially selected by the squadron's observation flight or by those of the affiliated brigade observation squadrons. They are recorded on the terrain analysis and coordination trace. TACT information also includes the line of departure and phase lines, holding areas, artillery targets, the location of the FARP, and other coordinating features such as grid intersection points. Traces are prepared by the brigade affiliate observation squadrons or by the attack squadron's observation flight for the respective areas. These are superimposed over the brigade anti-armor plan and are based on the terrain best suited for attack helicopter operations. The division-assigned observation squadron or the depth brigade observation squadron prepare the trace for the division rear area. Completed traces are approved at brigade and passed to the wing headquarters and coordinated with the division staff. The wing then issues an attack helicopter anti-armor TACT for the entire sector. The TACT is distributed to the division and brigade G3 and to all observation and attack squadrons operating within the division sector. The attack squadron is a self-sufficient tactical entity requiring a great deal of logistics support, primarily fuel, ammunition, and a forward battle damage repair capability to permit continuous operations. It carries the normal 3-day basic load of combat supplies, including aircraft fuel. For specific operations, the squadron deploys a forward arming and refueling point, which is normally located just to the rear of the forward brigades. A FARP is normally deployed by vehicle. Should distances, time, or tactics preclude the use of ground transport, it may be airlifted to the location. The FARP is responsible for its own defense, setting up a defensive perimeter and security pickets. It may be co-located with the unit echelon for added security and to simplify logistic support and communications. The location requires easy access to the main supply route to facilitate the handling of quantities of fuel and ammunition, firm level standings for vehicles and aircraft, and an adequately sized landing zone. The location should also provide for the concealment and dispersion of its elements and be free of enemy air and artillery activity. It remains as mobile as possible, maintaining a 30-minute notice to move status and only offloads the minimum quantity of ammunition. The FARP requires multiple in and out air routes which are masked against enemy radars and hidden against optical detection. A typical FARP layout would include areas for a landing zone, control and communications, fuel and ammunition stocks, refueling, rearming, and repair of aircraft and weapons, and for an aid station. Planning considerations also involve the number and type of aircraft that will use the FARP, the intensity of the operation, which affects the consumption of fuel, ammunition, and repair parts, air traffic procedures within the FARP area, separation between aircraft landing points and sighting of refueling equipment, safety distances for bulk fuel and ammunition stocks, as well as for the refueling, rearming, and weapons repair points, night operations, fire protection, and ground-to-air communications. The FARP is geared to handle between 2 and 7 rendezvous for each helicopter during an operations cycle, with each turnaround taking approximately 1 hour. The maintenance flights MRTs concentrate on quick turnaround repairs which assure a high degree of aircraft availability. This is accomplished for the most part by component exchange of avionics, weapons, engines, and transmissions. Downed aircraft, or those requiring extensive repairs, are recovered directly to the Wing Maintenance Squadron by vehicle, by helicopter, or by a one-time flight. The MRTs prepare the aircraft and the maintenance squadron completes the recovery procedure. Downed crews move to a designated pickup point or other location where other aircraft or ground units attempt their rescue. The attack helicopter squadron is ideally suited for situations in which rapid reaction time is important and where ground forces are inadequate or restricted by terrain. By using its speed, mobility, flexibility, and armor-defeating capability, the squadron can quickly respond to a threat, rapidly mass its fire units, and attack or delay the enemy. The squadron is an integral part of the combined arms team, significantly enhancing the anti-armor capability of the division in battle.
The Close Support Medium Regiment is a component of division artillery which provides intimate fire support for the units of a brigade. The regiment can quickly and accurately deliver a large weight of fire close in front of our own troops and can switch its fire rapidly from one target to another over a wide front. In addition, its network of observers provide the brigade commander with an important source of updated information on enemy activities across his front. The regiment is organized into a command group, 4 close support medium batteries, a target acquisition and support battery, and a headquarters and services battery. The medium batteries are made up of a battery commander's party.
a battery command post, 4 forward observation parties, 2 firing troops, and a support troop. Each firing troop includes a small command post with its reconnaissance detachment, 5 self-propelled M109 howitzers, and their ammunition resupply vehicles. The support troop includes an ammunition section, mobile repair teams, refueling and stores detachments, an ambulance, and a kitchen. The Target Acquisition and Support Battery comprises a battery headquarters located in the Regimental A echelon area, a target acquisition troop, a rocket troop, and a support troop. The battery commander functions as the Brigade Artillery Intelligence Officer and heads up the Artillery Intelligence Cell at Brigade Headquarters. He and his staff are primarily concerned with the location and silencing of enemy mortars directly affecting formation operations. They use intelligence reports, RPV imagery, radars, and observer reports in their locating activities, and direct the fire of any available guns and rockets to assist with counter-bombardment tasks. The Target Acquisition Troop is organized into a small command post with its integral reconnaissance element, the Brigade Artillery Intelligence Office staff, a survey section, a remotely piloted vehicle section, and a counter-mortar radar section. The troop provides surveillance information, target acquisition, and target engagement support. The survey section has a small command post and 5 survey pairs. Their main tasks are to provide accurate direction, location, and height data to the gun areas, and to equipment groups that will place all fire units and target acquisition elements on a common grid and fix registration and control points. The remotely piloted vehicle section includes a small command post, 4 launchers, and 2 ground control stations. It provides target acquisition and surveillance information and target support. The section detaches a liaison and analysis representative to the BAIO cell to assist with data interpretation. The counter-mortar radar section comprises a small command post located near the regimental CP, 2 counter-mortar radars, and 4 listening posts. They acquire location information on enemy mortars. They can also be used to adjust artillery fire for the regiment and help direct general support artillery shoots. The listening posts cue the radars providing coverage through their primary arcs. They may be assisted by the regiment's OPs and the sound-ranging advanced posts of the Division Target Acquisition Battery. The rocket troop includes a command post with a reconnaissance element and 5 multiple launch rocket detachments. It is used mainly for counter-bombardment and for the delivery of scatterable mines or improved conventional munitions. The support troop is similarly structured to those of the gun batteries. Its replenishment task is complicated by the wide dispersion of its associated elements. Please see productions involving the Division Target Acquisition Battery, catalog number 07507A, and the Multiple Launch Rocket Regiment, catalog number 25472D, for further information on the detailed operation of the RPV and MLR elements. The Headquarters and Services Battery is organized into an operations troop comprising a Fire Support Coordination Center and a regimental command post, plus a signals troop, a services troop, and a maintenance troop. The FSCC group operates a command post for the coordination of all indirect artillery fire supporting the brigade
as well as providing tactical advice to the brigade operations staff. The regimental command post provides the required technical orders to control and coordinate the fire of the guns. The signals troop maintains all communications at regimental level and links to higher headquarters. The batteries and regimental headquarters are interconnected by radio and, when possible, by line. The services and maintenance troops deploy into A and B echelon groups. The regimental A echelon includes the logistics command post, along with supply, stores, and maintenance detachments, and the unit medical station. The regimental B echelon comprises the regimental administrative command post and any elements not required forward. Within the brigade sector, the regiment normally deploys with observers and battery commanders well forward with the battle groups. The guns are located to the rear of the forward troops, about 1/3 of their range from the FIBA. The two counter-mortar radars are normally sighted well forward and to the flanks of the brigade, with their 4 listening posts positioned across the brigade front, close to the FIBA. The commanding officer's tactical command group is located at brigade headquarters, along with the Fire Support Coordination Center and the Artillery Intelligence Staff. The multiple launch rocket detachments are dispersed in hides from which they can deploy to cover the brigade front. The regimental A echelon area is located to the rear of the gun areas. The RPV area, with its launchers, ground control stations, and support vehicles, is sited well rearward of the guns. The B echelon area, including the battery office elements, deploys within the brigade administration area. The regiment's command, liaison, and observation elements deploy with their affiliated supported arm. The commanding officer joins up with the brigade commander, the battery commanders with the battle groups, and the OP parties with the combat teams where they advise on and coordinate all fire support activities within their assigned boundaries. The commanding officer establishes a tactical command group and a fire support coordination center at the affiliated brigade headquarters location. When not moving with the commander, the CO exercises command of the regiment from the FSCC. He carries out detailed fire support planning for the upcoming battle and coordinates the deployment of all artillery resources placed under command of the brigade. The battery commander's party co-locates with the mortar platoon HQ at the battle group headquarters. It includes drivers, technicians, and signalers, and forms the basis of the battle group's FSCC. The battery commander normally accompanies the commander of the battle group and provides fire planning support advice. Each close support battery deploys 4 APC-mounted artillery observation parties, each consisting of an officer, observation post technician, and 2 signaler drivers. The OP is usually located within the combat team's boundaries. Communications and liaison are established with the local commander. An OP normally maintains continuous observation, reporting information and engaging targets that present themselves or which are requested by the supported arms. Binoculars, telescopes, and medium and long-range night observation devices are used as vision aids. Laser range finders are also available for more precise measuring of distances and bearings to targets. Artillery OPs usually cover the main approaches to the brigade area and are integrated into the brigade surveillance and target acquisition plan. Batteries occupy reserved gun areas located to the rear of the forward battle groups, which are allocated by formation headquarters. Each covers an area of approximately 1 grid square, large enough for F and A echelons of a deployed battery. The regimental command post, with its signal troop and survey detachments, is centrally sited in one of the reserved gun areas, so as to provide good communications to the guns and to brigade and division headquarters. The regimental command post officer organizes and directs the activities of the CP. He controls the fire of the regiment and other allotted artillery, monitors and reports on ammunition expenditure, and passes on tactical information. He maintains communications with the commanding officer, the FSCC, and the batteries on 2 regimental nets, and operates a link to division artillery. The second in command of the regiment, operating from the regimental command post area, directs reconnaissance activities, coordinates the deployment of the regiment, organizes the defense of the gun area, and is assisted by the regimental sergeant major in overseeing the replenishment of ammunition. The battery deploys in a main gun area where it provides indirect fire support within a primary arc, down to a minimum range. The main gun area breaks down into a gun position and an echelon area for the support vehicles and equipment not required forward. It is normally located about 4 to 6 kilometers behind the FIBA. A temporary gun position may be occupied beforehand in order to prevent disclosure of the main position. It may be well forward so that guns can reach targets otherwise out of range, such as when supporting a covering force or carrying out depth fire tasks. Each battery also prepares an alternate gun area, which is occupied if heavy counter-bombardment or infiltration make the main position untenable. In this situation, all elements move to the alternate position as quickly as possible, taking only necessary equipment and stores to reduce casualties of personnel and equipment. The battery gun position consists of an area for the main command post and other headquarters elements. 2 troop areas, each containing their 5 guns and the troop CP, and an echelon area containing their ammunition vehicles. Elements are sited to ensure the efficient firing of the guns, to provide protection against ground attack, and to give ready access for ammunition supply vehicles. A dispersed layout allows elements to be deployed 300 to 500 meters apart, with the battery covering the better part of a grid square. It offers the best compromise between reducing vulnerability and the need to maintain effective internal command, control, communications, and local defense. The gun position may also be deployed in a close posture, wherein the troops and guns are located no more than 50 meters apart. This option allows for the optimum command and control over the guns. Urban locations present an additional deployment posture. With the ability of buildings to mask infrared signatures and enhance camouflage, urban deployments may be the preferred means of improving unit survivability. This may occur in spite of the inherent problems of communications, control, and the possible need to accept a lesser separation between gun platforms. Various types of artillery ammunition used by the regiment include high explosive shells and extended range projectiles, which can be fitted with point detonating, delay, or airburst fuses. Carrier shells, which eject the contents through the base of the shell. They can contain fillings of illuminating candles, colored smoke canisters, chemicals, leaflets, and various submunitions. Smoke shells with white phosphorus. Concrete piercing shells, which are used against pillboxes, strong points, buildings, or fortifications. Cannon launch precision-guided projectiles, which are used in conjunction with laser designators and employed against stationary or moving targets. Sense and destroy anti-armor projectiles, which are capable of detecting and firing intelligent submunitions at point targets. And free rocket projectiles, which incorporate high explosive and a variety of submunitions. Infiltration of sizable enemy forces may occur unexpectedly, often with little warning of an attack. Batteries are normally deployed independently and must rely on their own resources for local defense. After the technical requirements of sighting the guns have been satisfied, the gun platforms may need to be adjusted to provide adequate security against ground and air attack. The battery's best defense against enemy armor that has penetrated the FIBA is to go silent and attempt to escape detection. Only when necessary would they directly engage enemy tanks or other elements. In addition, arrangements are made with other batteries for support in case of an attack. Camouflage minimizes the possibility of detection and identification. A well-camouflaged position offers flash cover, concealed routes, and maximum concealment from observation. When leaving a position, spade marks and weapon pits should be filled, dumps and trenches closed, and litter hidden. These steps prevent enemy air photos from showing the type of weapon, strength, and departure route of the unit, as well as its deployment profile. Camouflage is an art that, if well applied, can be the difference between effectiveness and survival, or suppression and destruction. The task of the Close Support Regiment is to neutralize or defeat the enemy by quick and accurate indirect fire, or with direct fire when needed, and to help integrate all fire support into combined arms operations. Effective use of artillery demands good liaison and the close cooperation of all fire support and command elements, and the quick and accurate delivery of fire onto the target. The combat structure of corps, divisions, and brigades are essentially the same, each involving combat arms, combat support, and combat service support entities, with each formation incorporating a command and control element with a commander, staff, and the necessary communications capability, infantry, armor, and artillery units which provide the basis of combat power, engineer, signal, aviation, and intelligence units, which contribute to combat power, and organizations that provide medical, dental, supply, transport, maintenance, chaplain, welfare, finance, military police, legal, postal, laundry, bath, decontamination, and replacement support to combat forces. The defensive concept includes a covering force to fight forward of the main defense area, an infantry heavy force with a range of anti-armor weapons to stop and hold the enemy on an obstacle, and an armor heavy mobile force to conduct counter moves. The Corps includes a wide range of skills and equipments. It provides a complete tactical and administrative capability and is the most effective level at which the structure of the system can be established to meet the dictates of the defensive concept. The Corps organizational components include maneuver formations, Corps troops, and administrative commands. Its maneuver formations comprise 2 mechanized divisions, an armored division, a mechanized brigade group, and an armored cavalry brigade group. Corps troops encompass an artillery division, an engineer brigade, a signals brigade, an intelligence battalion, a tactical aviation group, and a military police battalion. Finally, the administrative commands break down into a service command and a medical command. In the defense, the division may be required to cover a frontage of up to 40 kilometers and to a depth of approximately 80 kilometers. This area provides maneuver space for its combat components and allows for the positioning of its combat support and service support elements. The mechanized division is structured to control ground and destroy the enemy in close combat. Its armored vehicles provide a high degree of tactical mobility and can fight in balance with armored formations. In defensive operations, its functions are to defeat the first echelon of an enemy force and to assist with the destruction of the enemy's second echelon. The combat structure of the mechanized division breaks down into a headquarters and signals regiment, a reconnaissance regiment, 3 mechanized brigades, an artillery brigade, an anti-armor battalion, an engineer group, a tactical aviation wing, an intelligence company, a military police company, a service group, and a medical group. An armored division is organized much like a mechanized division, except that it has 2 armored and 1 mechanized brigade instead of 3 mechanized brigades. The inherent armored protection, mobility, and firepower of the division enable it to operate over a large part of the battle area, conducting aggressive action in all types of operations. Brigades contribute directly to the combat power of the division. The mechanized brigade is made up of a headquarters and signal squadron, 3 mechanized infantry battalions, a tank regiment, an anti-armor squadron, and a point missile air defense battery. An armored brigade is similarly structured, except that it incorporates 2 tank regiments in lieu of 2 of the infantry battalions and does not have an anti-armor squadron. Combat support and combat service support is provided for the brigades from division troops resources. A brigade group contains a mixture of combat arms, combat support arms, and usually some combat service support elements. It is generally capable of operating independently over long distances to fulfill a variety of tasks, including blocking, counterattacking, and rear area security. Commanders' responsibilities involve the achievement of their missions and providing for the welfare of their troops. The command system is characterized by a single commander who both plans and fights the battle and is responsible for its outcome. He directs the personnel, equipment, and material committed to the task. The force structure and its operational activity must be designed so that it can be handled by one person. At each level, a commander responds to orders and direction received from his higher commander. Tasks are delegated to subordinate commanders and staffs with resources made available to assist them in meeting their responsibilities. Subordinate commanders enjoy freedom of action to plan and conduct their operations, and clear procedures are established for the succession of command. Command is the authority vested in an individual to direct, coordinate, and control military forces. Control is that authority exercised by a commander over part of the activities of a subordinate or organization not normally under his command.
We've also got a quick reaction force.
Command and control involves the continuous exercise of command authority over assigned forces and the uninterrupted use of procedures and activities by a commander in the accomplishment of his mission. The command and control process involves the planning, directing, controlling, and coordinating of operations. Planning initiates the process. It involves the commander's estimate and his subsequent concept of operations, from which the staff develop the detailed plan.
And ferry equipment's got to come.
The commander's direction is transmitted to subordinates as orders or instructions, stating the tasks, resource allocation, coordination details, and combat service support arrangements. Control ensures the assigned assets are being employed in accordance with the plan, and the activities of one entity are coordinated with those of another to maintain the pace and direction of the operation. The staff provides advice to the commander and support to subordinate commanders. Its tasks involve the collection and analysis of information, detailed completion of plans, preparation of orders and instructions, and monitoring the execution of operations. The staff assists subordinate commanders by coordinating the routine activities and resolving problems within the overall framework of the commander's plan or directions. Staff appointments may be categorized as personal, general, or special appointments. The commander's personal staff directly assist in meeting his individual needs and arranging his work and visit program. The general staff assist the commander with his overall command responsibilities. They are involved in planning, coordinating, and supervising the execution of operations and training, and arranging for the support needed to maintain the pace of operations.
Presently, the stay-behind...
Special staff provide the commander and general staff with advice and assistance in professional or technical areas. They hold specific appointments in the general staff branch.
Yeah, according to the Geneva Convention. Yeah, that's right. You have to make sure
There are also arms and services advisors who, although not classified as members of the staff, play an important role in providing advice and assistance to the commander and the general staff.
Okay, what sort of coverage have we got for the disc group? Okay, so
arms advisors are normally representatives of combat and combat support arms.
We put a section on machete jump.
Commanders of artillery and signal elements are located at the headquarters of the supported formation, while engineer and aviation commanders maintain liaison officers at their supported headquarters.
What have you got from Cora?
The commanders of various units and portions of their staff assume the added responsibility of providing advice on the capability and employment of their resources, both to the formation commander and to the general staff. Service advisors are the commanders of formation combat service support, medical, and military police elements. They normally maintain a continuous presence in the headquarters or detach a full-time liaison representative. The general staff is organized into G1, G2, G3, G4, and G5 branches. The G1 staff is involved with personnel administration, that is, maintaining manpower levels and the efficient employment, discipline, and well-being of the soldier.
Advanced Guard Company.
The G2 staff provides intelligence on the enemy for the planning and conduct of operations.
315 there. 30 hours. Okay.
The G3 staff is the preeminent staff branch and is involved in planning, directing, controlling, and coordinating operations and training.
Okay.
We observed engineer vehicles.
The G4 staff assists with arrangements for the logistics aspects of operations, including maintenance, supplies, accommodation, and administrative movement. The G5 staff assist with the development and execution of policies relating to local national authorities and the civilian population. The various staff branches are normally divided into two functional staff divisions. The Operations Division encompasses the G2 and G3 staffs and is headed by the Chief of Staff or the Brigade G3, who are responsible for all staff activities in the headquarters. The G1, G4, and G5 staffs make up the Administration Division, directed by the Assistant Chief of Staff Administration or the Brigade G4. Grouping involves tailoring a force to carry out specific operational tasks and will set out the command relationship within a task-tailored organization. Standard affiliations promote stability. The standardized grouping of units develops and increases combat effectiveness through mutual self-confidence and an understanding of unit procedures. More specifically, affiliations generally involve service battalions working with the same brigade, forward observation officers with the same combat team, tank squadrons with the same battle groups, and engineer troops with the same battalions. The command relationship within a task-tailored group is normally expressed in terms of a unit or element being under command, in support, or in location. Under command carries the meaning of full command for tactical and administrative matters, and is normally used to assign corps or division troops to subordinate formations. At battle group or combat team levels, the meaning becomes tactical without any administrative implications and is applied mainly to reconnaissance, infantry, point air defense elements, armor, and anti-armor. Under command for movement implies a delegation of control only for movement. An element assigned in support of another unit or formation gives the receiving commander the authority to call for and direct its operational capability to accomplish his mission. In support usually applies to artillery, engineers, and tactical aviation elements, command of which is normally retained at the highest practical level. In addition, individuals may be allocated to a particular unit or subunit, such as a FOO to a combat team, or a forward air controller to a battle group, which by their presence indicates the in-support function.
Roger, Charlie 01.
The in-location relationship involves a unit or subunit that is deployed within the area of responsibility of another commander. That commander has no authority to direct the operational activities of that force and must coordinate its needs for real estate, road space for movement, defense, and the like. This term generally pertains to elements such as electronic warfare detachments, communications nodes, area air defense elements, and anti-armor weapons. Operational regrouping often means that certain administrative adjustments must be made to ensure that the units are adequately maintained. Under command for administration involves a complete transfer of responsibility and all that implies. Under command for administration, less certain specific items would be affected when the transfer is of a temporary nature. It signifies a considerable amount of support activity will be required from the gaining formation or unit. Under command for daily maintenance means that a unit is placed under a formation for the daily provision of combat supplies and other immediate stores and services. The relationship is used if the attachment is of short duration and the parent formation retains responsibility for all personnel and logistics matters. A fundamental function underlying decision-making within a formation headquarters is the planning process. This is a procedure for deciding what has to be done and how to do it, incorporating a logical sequence of collective reasoning which leads to the best solution to a problem. This process starts when a commander receives a task or when, on his own initiative, he wishes to prepare for a foreseeable contingency. It is completed when orders issued to subordinate and supporting commanders have been executed. The process consists of 7 steps: receiving or assuming tasks, analysis of the task and definition of the aim, initial concept of operations, staff checks and estimates leading to the final concept of operations, preparation and issue of orders, and controlling the execution of the operation. The first step, receipt of the task, may be by verbal means with confirmation in the form of an operation instruction or by a written operations order. This starts the planning process with the calling in of the Chief of Staff and the issuing of a warning order.
Matter we were discussing.
In the second step, the commander identifies those tasks that are essential to the accomplishment of the mission. He does this by reviewing the higher commander's analysis of enemy intentions and thoroughly understanding his concept of operations. He examines his assigned tasks and identified constraints. The end result is a simple, clear statement of the aim detailing what must be done, along with any limitations regarding time, space, or troops available. During the third step, the commander develops a preliminary concept of operations to formulate a framework for staff checks and provide planning guidance to the staff. He will likely carry out an abbreviated estimate as part of this process. Throughout the fourth step, the various staff branches will check the supportability of the commander's initial concept and recommend modifications. These studies may be structured anywhere from a basic staff check to a wide-ranging estimate and indicate possible courses of action. They normally involve the outline of fire support, engineer, signals, surveillance, intelligence, deception, aviation, and logistics plans required in support of the operation. In step 5, the staff, armed with the available facts and a knowledge of the feasibility and limitations of various options, can complete the detailed estimate. In step 6, detailed plans and operations orders are prepared under supervision of the Chief of Staff and approved by the commander. They are subsequently issued to the appropriate subordinate staffs, formations, and division troop units. In the 7th and last step, the commander and staff supervise the execution of the operation until it is completed, or until modifications are made due to a change in the aim or the situation. Feedback of information is received through reports and personal observation, which measure whether or not the mission is being accomplished. As the situation changes, refinement of plans and orders takes place, and ongoing decision-making is required. The operational planning process is again repeated, but in a modified form. The commander is responsible for analyzing his task, defining his aim, and giving the staff planning guidance for a preliminary concept of operations. The staff are then responsible, through staff checks and estimates, to define the options available to the commander, which will lead to mission accomplishment. The staff must be thorough, honest, objective, and systematic, with a great deal of coordination and dialogue between the various cells throughout the planning process. Staff planning is a current and continuous activity in which the commander and his staff work as a team. The structure of corps, divisions, and brigades is based on a definition of combat tasks and the matching of the necessary components and supporting functions to suit the overall requirement. The division organization makes the most effective use of corps resources. Its staff structure and capability to tailor forces provides a sustaining capability for long-term operations.
In operations, a commander will constantly seek to maintain the initiative, to gain information about the enemy, and to ensure the security of his own force. These requirements can in part be met by active and aggressive patrolling. Even with the advent of new weapons and equipment which improve the commander's capability to obtain information and inflict damage on the enemy, patrolling continues to be important, as its use is limited only by the ingenuity with which it is employed and the energy and skill of its members. This production is infantry-oriented, primarily at the battalion level. The reconnaissance function of other brigade and division troop units, tactical aviation and special long-range patrols are handled in separate productions. Patrolling requires the highest degree of leadership, discipline, initiative, resourcefulness, skill in weapons and fieldcraft, and the will to win. A patrol is a detachment sent out to perform an assigned mission, normally involving reconnaissance or combat. The requirements of the mission determine the size, organization, and equipment of a patrol. A patrol may vary in size from 3 individuals carrying light weapons and minimum kit to a specially armed and equipped company-sized group. Patrols are used to gain information on the strength and disposition of the enemy and on the terrain, to deny information to enemy patrols about our deployment and approaches to our positions, to harass the enemy in his home areas, to provide security by clearing areas of the enemy, checking minefields, guarding the flanks, maintaining contact with other organizations, by covering gaps and giving early warning. To gain and retain the initiative by destroying the enemy and subsequently dominating the ground between opposing defended localities. To act as escorts for reconnaissance parties and key personnel, and to provide a degree of security for selected locations and installations. Patrols are classified as reconnaissance, fighting, or standing patrols. Reconnaissance patrols gain information by observation and operate primarily by stealth. They avoid fighting and their size is kept to a minimum. Their more routine tasks include collecting information on the terrain and on enemy activities, locating and defining the extent of enemy positions, obtaining details of enemy obstacles, investigating suspicious noises made by the enemy, and conducting a reconnaissance of areas that may be contaminated by fallout or chemical attack. Fighting patrols are tasked to intercept and destroy the enemy, to disrupt or destroy enemy headquarters, communications facilities, or logistics installations, and to capture prisoners or equipment. They may also be tasked with protection of various specialists, parties, or activities. Fighting patrols are seldom smaller than a section or larger than a platoon. Each patrol is large enough to be able to fight to achieve its mission, and its members are equipped with the weapons, special equipment, or vehicles considered necessary to achieve the mission. Standing patrols are established to give early warning of enemy movement and to prevent enemy infiltration. They should be kept as small as possible, usually from 2 or 3 men to a section or more. When in position, the patrol is well concealed with all-round protection, and it is prepared to fight in self-defense unless specifically ordered not to do so. They watch approaches that the enemy is expected to use, cover the dead ground in front of and between defended localities and the forward edge of the battle area, and watch the entrance to all minefield lanes which cannot be covered from the main position. Unlike other patrols, standing patrols do not maneuver to achieve their mission. They guard with direct and indirect fire, as well as observing and reporting using, if possible, both radio and line communications. All patrols, irrespective of the level at which they are ordered, must be adequately supported by all available indirect fire with patrol personnel trained to call down fire as required. Staff functions surrounding patrolling involve planning, organization, and coordination of patrol activity, provision of briefing data, extraction, recording, and dissemination of information gained from patrolling, and arranging unusual transport and supplying special equipment. The patrol policy for the division front includes authorization for types of patrols and their missions, objectives of the overall patrol effort, coordination of patrolling activities, and any imposed restrictions. Brigade and battalion plans are made within the framework of this policy. Patrols are coordinated by the Brigade G3 and G2 staffs in accordance with the patrol policy and the requirements of the Surveillance and Target Acquisition Plan and the Intelligence Collection Plan. These requirements are published in the form of a patrol task table, which contains the basic tasking and coordinating information on each patrol to be sent out. A task table normally covers a 24-hour period, giving the tasked unit time for pre-planning, rehearsals, briefings, acquisition of needed information on the ground and on the enemy, and acquiring any special equipment necessary to complete the mission. Reconnaissance and fighting patrols are planned, tasked, and coordinated by division and brigade, while standing patrols are planned at company level and coordinated by battalion headquarters. A battalion can, however, mount any type of patrol within its area of responsibility. Coordination is an ongoing process involving various headquarters, continuously updating information and interrelating activities. General coordination measures include patrol boundaries, which are established and advised to all concerned, fire plans and activities associated with other arms and units, making available technical information on minefields, water obstacles, and going for armored fighting vehicles, and advising flanking units and formations of patrol activities to ensure that operations in one area do not prejudice the success of others. The brigade staff ensure that all relevant information is made available to patrol leaders. This includes the latest maps, air photos, and any other information which will assist the success of the patrol. Patrols will normally move on foot, as well as by vehicle, by helicopter, or by small boat. Whatever transport means is employed, the basic principles of movement and security must be practiced and all equipment thoroughly prepared. The choice of conveyance will be determined by time available and distance to be covered, by the weight of weapons and equipment required, by the degree of stealth needed, and by the contamination level of the patrol area. As soon as a patrol returns, its commander is debriefed by the battalion intelligence officer on all aspects of his mission. The resulting information is then passed to the Brigade G2, where it is sifted, analyzed, and cross-checked. It is then processed into intelligence and disseminated as soon as possible. Patrolling is an essential function, providing detailed information and increased security within formation boundaries. It is continuously conducted at night and during periods of poor weather and low visibility. Patrolling is an age-old art, but is still an essential part of the modern battlefield.
The airspace covering the communications and combat zones is a busy and constricted area. In addition to enemy air activity, other elements which can be expected to be active in this airspace, and especially over the combat zone, include aircraft on counter-air, air interdiction, and offensive air support missions, aircraft in transit to and undertaking close air support operations, helicopters engaging in airmobile, resupply, and anti-armor operations, tactical air transport aircraft employed in airborne or air-landed, air logistics support, and casualty evacuations operations. Drones and remotely piloted vehicles on target acquisition and surveillance missions. Gun and rocket artillery engaged in indirect fire missions, and various types of air defense weapon systems. The airspace control system has been designed to function in conjunction with these numerous concurrent activities. The Theater Air Commander is designated as the Airspace Control Authority and given the overall responsibility for the planning, organization, and operation of the airspace control system.
Exactly, sir. Let me get this up on the board.
He implements the system through the Airspace Coordination Center, which is jointly manned by Army and Air Force staffs.
Okay, Tango,
The airspace control system consists of a number of coordination and control agencies, several early warning and control radars, with their associated communication networks, surveillance and identification resources, and control procedures. Control and coordination elements are linked with each other and with the Airspace Control Authority by communications and procedures to form an integrated system. The purpose of the airspace control system is to identify aircraft through procedural or electronic means, to alert the defenses when aircraft are identified as hostile, to control and coordinate all air defense resources, and to prevent the destruction of friendly aircraft.
This one was, I think, maybe one of them would be more
The Airspace Control Authority plans, organizes, and operates the airspace control system through the Fire Support Coordination Centers established at each level of command. In addition, land and aviation commanders have a requirement to operate aircraft, command, surveillance, and weapon systems within their area of the combat zone, and they participate in airspace usage planning through their associated FSCC. Airspace coordination in the combat zone generally involves processing requests for the temporary use of airspace, coordinating artillery and air defense fire with offensive air support missions and tactical aviation activities, and ensuring subordinate formations comply with current airspace control measures.
have 54 aircraft available.
Corps and division commanders coordinate overall control parameters of the Air Commander's airspace coordination orders. The division artillery commander is responsible for airspace coordination within the division area. This function is normally delegated to the supporting air defense commander. The Fire Support Coordination Center is the primary airspace coordinating agency, involving its artillery operations, air defense, air and aviation cells. The FSCC's specific airspace coordination functions are to correlate information and data and resolve potential airspace usage conflicts, to maintain an airspace usage map, and keep informed on the current status of the air defense and aviation activities, to maintain and disseminate current information on all defended and restricted areas, air corridors and air traffic control zones, on prearranged indirect fire missions, on any major aviation operations, on all pre-planned offensive air support missions, and on any information concerning enemy air and air defense activity, and to relay information concerning air defense warnings, weapons control orders, rules of engagement, and identification criteria within the division's area.
Jerry?
An airspace coordination center may be established within the division FSCC on an as-required basis to coordinate aircraft movement and provide for timely target identification and engagement. Airspace control and coordination is normally achieved by a combination of procedural and positive control measures. Procedural control is restrictive in nature and consists of measures which are promulgated in various plans, directives, and SOPs by the Airspace Control Authority. These measures include areas and zones, air corridors, temporary restrictions, and other regulating directives, which are designed to prevent or minimize interference among users. Airspace control area and sub-areas are the basic geographical elements contained within the operational commander's area of responsibility, wherein control is provided as an integrated system by the ACA to meet the needs of all users. A high-density airspace control zone is established when an intense ground operation is planned or taking place. Its size is kept as small as possible, and friendly air activity within the zone is limited to aircraft tasked to operate in the area. A restricted operations area reserves airspace to suit a particular operational need. These areas include airdrop areas and weapons engagement zones. Requests to activate an ROA are made by any commander through their respective FSCC to the Airspace Control Authority. A weapons-free zone is a temporary airspace restriction around a critical asset, which merits special air defense protection. All friendly aircraft must avoid a WFZ unless prior approval has been obtained from the designated controlling authority. Base defense zones are controlled areas around airfields, used to enhance the effectiveness of their ground-based air defense weapons. A low-level transit route is a temporary corridor of defined dimensions passing through areas containing short-range air defense weapons. Use of these routes reduces the risk to friendly aircraft and minimizes the weapons-free constraints throughout the area. Air routes are used in the communication zone for the movement of reinforcement and resupply flights through the rear area air defense systems. Transit corridors are established to route friendly aircraft through air defenses in the communication zone and to provide a means for aircraft to transit into the forward area where they link up with the low-level transit routes. Special corridors are similar to, but much larger than the LLTRs. They facilitate the passage of large aircraft formations, allow greater navigational tolerance in bad weather, and minimize risk to friendly aircraft at medium and high levels. Time slots denote a period during which air defense systems are restrained to permit other users greater freedom of operation. Altitude and airspeed control signifies a defined height and speed band within which aircraft may fly. It normally functions as a supplement to other forms of identification and is used in conjunction with other parameters. A traverse level is the vertical displacement above a short-range air defense weapon system. Here, an aircraft can cross the area when it is unable to obtain direct clearance from the air defense system, or when it cannot comply with other recovery or transit procedures. Coordination level is a height above and below which Air Force and Army-controlled traffic must be coordinated with each other's agencies. This coordination is required to minimize the risk of collision between fast and slow-moving air traffic. Restricted arcs result in areas in which the fire of an individual SHORAD weapon is curtailed to a weapons tight or weapons hold status. In addition to the above restrictive measures, Corps and division agencies may establish airspace coordination areas, which allow the simultaneous attack of targets near each other, normally by multiple fire support means. An ACA prevents conflict between artillery and air traffic by having artillery fire cease at a specified time or on the happening of some event, by keeping aircraft clear of the trajectory of artillery rounds or rockets, by separating targets, and by a geographical feature.
Are there any air defense installations protecting that you know of?
Informal ACAs may be established at brigade and battle group levels, which greatly simplify the coordination function. These involve assigning individual sectors for fighter and artillery operations, which are laterally separated by a restricted maneuver area. An altitude restriction for fighters operating above a restricted maneuver area, the limits of which are determined by the shell's trajectory and the gun barrel line. A time separation, which allows fighters and artillery to share the airspace over a restricted maneuver area. And designating separate sectors with maximum aircraft and minimum trajectory altitudes to enable continuous attack of targets. Positive control is a minute-to-minute activity which relies on real-time data to achieve aircraft identification, tracking, and routing. This type of control is particularly difficult within the forward area of the combat zone due to the speed and intensity of activities and the lack of electronic control devices for short-range air defense weapon systems. Positive control is assisted by high to medium-level air defense weapon systems, which generally have a built-in electronic identification and tracking capability, and the associated command and control communications. Positive control may become unworkable due to the volume of individual activities, limitations of radar coverage, failure of navigation, communications, or identification systems, or because of enemy attack. Should any of these situations arise, procedural control measures will be adopted to supplement the deficiency. The routine coordination of airspace control activities is assisted by temporary airspace restrictions which are imposed in response to a commander's operational needs. Brigades and divisions forward any required changes to these restrictions to the Airspace Control Authority in the form of airspace control requests. Once approved, they are promulgated on a daily basis through an airspace control order. Airspace management is a complex activity with great potential for user confusion and conflict. Full positive control is flexible and highly desirable, but is equipment intensive. Procedural control depends less on equipment, but imposes many more restrictions on all airspace users. Control measures do, however, promote the safe and timely use of the forward airspace and assist with the flexibility of close air support operations.